And stream starts now. Hey, welcome everybody to the Game Dev stream. I'm your host, Kikushie, and today we're going to be making a shmup game from scratch. I'm going to be using, I got Unity here. We've also got Visual Studio Code for the coding. Firefox with all of my history removed. So if I start to search for something like Unity, it's not going to bring up any weird search results. We got Audacity here for doing any sound effects I need to make, like pew pew. And then we have Krita for making the graphics. No one's actually sent me any graphics for the game yet, so it's all gonna have to be hand-drawn in Krita. That should be fun, but I'm gonna do it real fast because I want to focus on the programming. So I hope everybody's having a good day. If you've got any questions, feel free to ask. Let me hydrate real quick here. And now I'm going to look at my volume meters to see if the volume is good. It looks pretty good. The music might be a little bit on the loud side. But it looks like the peak of the music volume is about average volume here. Your sketch is a chaotic mess. I mean, when you see my graphics, you're gonna feel really good at drawing. Or maybe you are already really good at drawing. Then you'll just feel, I don't know. But my art can only make you feel better about your drawings. Is it tough going? Oh, is what tough going? I'm sure. Oh, the art. I'm not sure I'll be able to sort it all out. It's your art after all. Yeah, exactly. That's kind of I kind of use that as my my fail-safe, I guess. Is if I don't what was I gonna say? My art's bad, but I at least try to make it look good, I guess. Or yeah, if it looks good, even if it looks bad, at least it looks good. Or maybe if it looks funny, that's good too. But all right, let me get started. Oh right, I have W split around here somewhere. Here it is. So I can use this to count how much time I actually spend working. Hey, what's up, Maven? Are you coding, son? We're about to. I got my coding here. See. Wait, why is my enter key not? Oh, I'm not even hitting enter key. That's right. Yep, we're coding. We're having a good time. How are you doing? How are you doing, Raven? Hold on. Whoop. Why are there reference counts up here? I haven't actually customized Visual Studio Code, so that's a little bit. Can I disable those? No, okay. But yeah, we're good. All right, let's. Yeah, so I got W split here. So I can actually time roughly how long I spend on this, and yeah, we'll see how it goes. Just woke up trying to properly boot up with a cup of coffee and some sunny setup. Oh, that sounds amazing. I'm glad I already had dinner or I get hungry from hearing that. That is awesome. Time for some if-then statements. Yes. If you are ready, then let's begin. Else, well, let's begin anyway. Okay, let's make this the official start here. So we're gonna go new. And I already checked that this doesn't dox me. My name is Cuckoos. We're gonna call this Kikushie's Dev Stream Shmup. And we're gonna make this a 2D shmup because I don't know how to work that. I don't know how to work that well with 3D. I'm a lot more experienced with 2D, and it's just easier to make because we can just draw stuff in Krita. So let's create this project. Now we just sit back. Probably should have done this earlier, but yeah, if you have any questions, you can feel free to ask. Now's a good time to. I mean, I guess I'll just leave the timer running. It's fine. Boop, boop, doop, boop. So I guess my plan. So it's always good to I think plan things out before you start developing them. So my plan is to make a shoot 'em up. We're gonna make a short stage. I probably don't have time to Okay, so usually what I like to do when I start any project is get it into a state where I can run it as soon as possible. Because that way, A, I can test it by running it, and B, that way you can have fun as soon as possible. Because it just feels really good to see the fruits of your labor, basically. Or at least it does for me. So I like to, the first thing I'll do probably is make a character, make a player character. You know what? I can do that right now in Krita. New. I don't know how big to make these. The brushes in Krita are pretty big, so I kind of want to make it a big canvas and then just shrink it down to the size I need. Actually, no, that's too weird. Let's make it roughly the size I want it to be. So if the screen is, what is this? 1,000 pixels and 80 tall. Then let's make our player character, I don't know, maybe like Touhou character. It's like maybe 1/5 of the screen. Maybe like 200 pixels tall and I don't know, 150 wide or something. Oh, wrong way around. Maybe something like that. Okay. All right. And this brush is too big. Okay, I haven't used Krita that much, so bear with me as I remember how to change the size of my brush. I know it's somewhere like really obvious. Where's the brush size? Oh my god, it's so much harder to do this when you're on stream. And you're like, oh, that just makes the zoom bigger. How do I change my brush? Oh, it's up here. Here it is. Okay, let's change the size like 5 pixels, I guess. Sure. That's better. Okay. So we got our project. That's good. Let's make a little player character. Let's see. So you think you're making a bullet hell? Sort of, yeah. Maybe not quite hell, maybe like bullet heck, if you know what I mean. What kind of character should we throw in here? Who should be our MC? I actually do have some graphics I could use, like let's see, where's I have like I could use other stuff that I've drawn before if I wanted to like take a shortcut, I guess. So like there's this thing. Can I open this in Krita? Open with. Dang, I can't open this in Krita. What if I just drag it on here? Insert as new document. Yeah, so I could use like the Choco Jacks that I drew, for instance. But like, I mean, like you could shoot from the horns, I guess, like pew pew pew. Or I also have an Aussie, but I think if I'm going to use an Aussie, he might be the boss, just because I saw he was making a shoot 'em up too, actually, and he made his own face the boss. So, you know what? I don't know why I have the timer going when I'm talking, but who cares? So yeah, so like Aussie, I think, well, I feel like he should be the boss. But yeah, so we could use a Choco Jacks, or I could just draw a player character. The thing that would be weird about this, I think, besides the fact there's a floating Jack's head, is the fact that her eyes are looking this way, but like she'd be shooting up, and that's just weird to me. So let's just make a short little picture here. Let's make the background. Oh, nice, I can do that. Okay. Okay. Where's my paintbrush? I don't know. I'm really uncreative, so I'm just gonna draw. Let's pick a color. It's a nice color. Okay, so color design is actually pretty important in games and in general. Let's see. So Choco Jax is gonna be a boss. She could be, or maybe Ozzy will be the boss, and we have little Jackson flying around shooting at you. She can be like the mid enemy, like the fairies in Touhou. Yeah, perfect. We have the dragon enemies. So yeah, I think color design is really important in like general. So first, let's pick a color for our bullets, or for the enemy bullets, because in a bullet heck game, you want to make sure that the enemy bullets are really easy to see, and they like really stand out. So probably something like I don't know, something like a red, for instance. Like red, if you see like red things coming at you, you want to dodge those. That could be like our bullet color, or possibly yellow. The only thing is that if we're gonna have explosions, there's some shoot 'em ups that make their explosions red and the enemy bullets red, and so when stuff explodes, it's really hard to distinguish the enemy bullets from the explosions. So I'm not a fan of that. I am, however, a big fan of cave games, which usually have some like cyan colored bullets, like this, for instance, and those are pretty easy to see too. Also, I believe biologically our eyes are most red and green basically stand out to our eyes better than anything else. So probably one of those will be a bullet color. Let's do green bullets, pew pew pew. Like a salad, bullet salad. Choco Jax is Yachie. Oh, who's Yachie? Is that a Touhou? So Choco is just those normal grunts you take down. I wonder how she'll react to that. Well, she'll have to deal with that. Let's go with, I mean, I guess it doesn't really matter for a prototype, but it would be kind of a pain in the butt to change my color design in the future. Yellow bullets, maybe? I think what a Touhou game would have. Touhou has like yellow lasers and stuff. Yeah, let's make the bullets yellow, I think. And then your player bullets might be cyan, for instance. And the enemies, Well, the enemies, if it's like Choco Jacks or whatever, the enemies are like multicolored, so they should be fine. So yeah, we can make Wing like yellow bullets. Maybe I'll do like that looks like a pretty good bullet color. But then that means that our player character should be a completely different color. Maybe like some blues. All right, we'll make our player character. Actually, let's make our player character some shades of purple. Or like a Reimu. Like Reimu's red, right? So we can have like red, and we can go like a, I don't know. Hold on. Let's make them purple. So we can make like a. This is what you do. This is what we do when we prototype. We draw it. Hold on. I'm gonna have to fill it in because you're gonna have to be like a. Okay, let's see. Oh, also I want to make a hitbox actually. So. Okay, let's do this. Let's do this smart. I'm gonna make a circle first of all. Okay, and then can I fill this in? This is what happens when you don't. Oh. Hold on. Magic wand. Magic wand. Where's the selection criteria? Fuzziness. Let's turn that up. Grow shrink selection. Yes, please grow it a little bit. Maybe like 3 pixels. There we go. There we go. And let's fill this in. Nope. Okay, well, there's a really stupid way to do this. What does this do? I don't know what this does. Paintbrush. Wait, what? Oh, because I need to pick this thing. Okay, well now it's... Why is... Okay, well that worked. Alright, there we go. Alright, so that's going to be our ship, I guess. She is a Touhou character. She's a tortoise dragon. Oh, cool. This Choco Jack's Yancha. This is like beyond Yancha. This is that dude from One Piece who can get chopped up. She's pretty advanced. Okay, so I guess this is kind of an ugly player character, but I mean, this is just a prototype, and I've already spent 10 minutes doing absolutely nothing, so I'll just draw random stuff. Let's pick a color for the eyes. Give me a white, maybe. Okay, this is a bit big though. Maybe like... This is a spooky looking... let's make him like the Pac-Man ghost. That looks pretty good. Okay. All right. And then I guess we're gonna shoot little... Yeah. Oh my god, this was... Making graphics on stream was a mistake. Wait, let's give it some pupils. Maybe not quite dark, maybe like that. Let's shrink this. What are these? I haven't used this thing enough. Is this what I want? No. What's this one? Oh crap! Nope. Wait. Redo, please. Okay, this thing is. That's too small. Okay. Wait, is this a hard edge pencil? Hold on. What is this thing? Whoa, why is this so big? I don't want a hard edge. Maybe like this. Okay, how about that? There we go. Looks like a Pac-Man ghost. Hey. I have no idea what I'm doing. Oh, whoa. Okay, this is... I don't know. I don't know what else to do. Okay, there. No, that just looks too weird. Okay, there. And then we can... Yeah, alright. Oh, you know what? Let me make something to show where the hitbox is. So, new layer. And let's make it's a color. What's a good color to show where hitbox is? Like, maybe like a blue. Yeah. Maybe like around here. Okay. We're gonna put the hitbox right here. That doesn't look... That does look pretty bad, but alright, there we go. That's gonna be where our hitbox is. Alright, let's see. Export. Don't dox me, please. Okay, good. Documents. Unity projects. Oh, you know what? Let's make some folders. So we got the assets folder. Back to Unity. Hey, what's up? What's up, Tsundere Tube Worm? No? Small hitbox must be Rainbow Shard. Yeah, exactly. Yeah, hope you're doing good though. Nice to see you. Welcome to the stream. We're gonna start actually making the game now. Well, first let's do some organization. So we got a scenes folder. Let's make a folder for textures. We're gonna need a folder for scripts at some point. And we're gonna need a folder for audio. Oops, excuse me. There we go. So let's start there. So we're gonna save this in the assets textures folder. We're gonna call this player.png. Okay, yeah. Save. Okay. And we're gonna go into Unity. All right, so obviously, as you can see, we've already spent, what, 12 minutes, and all I've done is made a really ugly smiley face. But okay, let's make our player character. So, oh, I need let's see, here's my scene. Let's see what our camera looks like. So, orthographic, yep, size. I'm gonna make the size of this play area. So I'm gonna make this game a 720 game. I'll make it like 1280 by 720. Okay, near plane, far plane. Okay, looks good to me. Yep, all this looks good. Okay. We gotta zoom out a bunch to get to. There it is. There's our screen. I guess we'll make it a vertical. I guess we'll make it vertical, although Touhou is usually like in half the screen or something, right? So maybe I'll make like this half of the screen the gameplay or something. Guess we'll see. But let's stick our player character in here somewhere. So we'll make a game object. All right, we gotta remember, we're gonna make this a real quick shmup here. I'll call this the player. Now, one thing I'm gonna do here is I'm gonna make another object inside the player for the sprite. It's really important in Unity, and probably like this is probably applicable to any game engine. You want to make your sprite, your graphics. Let me turn down the volume a bit. You want to make your graphics like a separate game object from your root game object. That way you can, say, move the appearance of your character without moving the center location of your character. And you can also do things like transform the appearance of your character, do rotations and scaling and such, again, without affecting like hitboxes, for instance. Or you can apply the same transformation to the hitboxes as well, and so on. But yeah, just generally you want to have your sprite and stuff on a sub-object, I guess. Child object. Okay, so 2D object sprite. Oh, well, in that case, boop. Delete this, we'll call this sprite. Let's see what we have here, the sprite. So if I recall correctly, I can just drag this texture onto here. Boom. Where's our sprite? Should be at 0, 0. Is it that thing? No. Oh, you know what? We got to go to this thing first of all. Okay, sprite. So we actually have to set this up. Pixels per unit. I'm going to make it 1 to 1. So normally with a default of 100, actually if I do that, no, that's just going to be weird, I think. I like having a 1 to 1 pixel to pixel ratio. Okay, pivot center. Yep, clamp, bilinear. I mean, if we were doing pixel graphics, we'd probably make this point filter instead. You know, I'm kind of tempted to do pixel graphics and make this thing like I don't know, 0.1 pixels per unit or something. But no, let's just keep it simple. We got 1 pixel is 1 pixel in the game. And apply. There we go. That's what was missing. Now our sprite is 200 or so pixels high. You can see it's kind of off center because I'm bad at this. Let's actually move that. So here's one of the advantages of. Okay, hold on. Why is my player over here? Player is going to be at 0. And we're going to put the sprite. Let's center it on the player first of all. Okay, so here's one of the reasons why we put the sprite on a child of the player, because we can move it. There we go. So the hitbox is centered. Maybe like 70. There we go. Yep, now the crosshairs are centered on the nose, and if we go here and we make another game object. Wait, can I just make one here? physics. No, probably not. All right, I'm gonna call this. I'll call this the hurt box because this is where you get hurt. And we're gonna come here, component. I'm gonna add a. Okay, so for Unity to do your collisions for you, you need a few things. I believe you need a rigid body first of all, and it's not going to be simulated because our player is not going to use physics. Body has been taken out of the simulation. Okay, wait. Wait. Hold on. Kinematic. There we go. Okay, I think I do. Let's use full cinematic. Should kinematic and kinematic static collisions be allowed? Yes. Okay, so kinematic means that we're going to control this ourselves with arrow keys, and we're not going to control it like a car, for instance. We're just going to like you press left, and it's just going to move left. We're not going to have acceleration or anything. For a shoot 'em up game, I find acceleration. Well, it makes the game really difficult. And you know, like Touhou doesn't have acceleration, for instance. You press left and you just move left. So the box of pain, exactly. Jack's Pop, pain. What's this thing? Emote. All right, so now we got our rigid body. So that means that Unity will now let this buddy participate in collisions. Now let's give them a box collider 2D. Although we could use circles, but we'll keep it classic. We have a box collider. How big does that nose look? Like 10 by 10? That's pretty good. Yeah. Okay, there's your hitbox. Your hitbox is literally 10 by 10 pixels. I don't think we need a physics material. Trigger? Nope. That's got to do with collision detection. And if you like two triggers, for instance, won't collide with each other, and that could be a problem. So there we go. Oh, we also need to change the layer this is on. Where is that? Project settings. Physics 2D. Should have some layers. Here we go. Oh, I have to actually make the layer. Hold on. Add layer. So we're gonna have this is gonna be the player hurt box, and then we're gonna have a layer for player bullets. Bullet hit box, and we're gonna have another hit box thing called like enemy hurt box. And the enemy hurt box will only be able to collide with these two layers. And we're also going to have an enemy bullet hitbox. And the bullet hitbox can only collide with a player hurtbox. And we're going to set that up now. Let's just uncheck. Can I uncheck all these? Okay, good. And then I'll like figure out which ones I want later. So this is really important for optimizing your game, and because if we're going to have a lot of bullets, we don't want Unity to compare all the bullets with each other, for instance, because enemy bullets can't collide with each other and player bullets can't collide with each other. So reducing all those collision checks is going to make the game run way faster than if we forgot to do this step. So let's see what we have here. Oh God, why is it sideways? Enemy bullet hitbox can collide with player hitbox, hurtbox. Enemy hurtbox can collide with the player and the player's bullets. The player's bullets can collide with nothing else, and yeah, that's it. These are the only collisions we can have. Wait, enemy hurtbox. Wait, enemy hurtbox collides with player bullet, right? Okay, good. Yeah, okay, yeah, that's it. These are the only collisions. Player bullet hits enemy, player hits enemy, and enemy bullet hits player. Perfect. Well, Cuckoo, I'm gonna step out. Got a collab and happen. Yo, nice. Hope you have fun, Maven. Have fun making Touhou game with turquoise grunt enemies year round. Thanks for coming by too. I hope you'll have an awesome collab, Maven. Also, shout outs to, even though you're already in the chat, Maven the Storyteller. Sounds like they're gonna have, what collab are you doing if you have time to tell me? Or if not, you know, hope you have fun. They were playing. All right, so there we go. We got our physics. I think we can just ignore the rest of this. Oh, see, SCP. Oh, yeah, that looks like it's going to be super fun. If I didn't have this stream scheduled, I'd probably join you, because that sounds really fun. But yeah, hope you have fun. And yes, good luck. Hope it won't be scuffed like mine was, like this stream is. But all right, so now we got our player. The hurt box is going to be on the player hurt box layer. In fact, let's just put this whole thing on the player hurt box layer. Yes, change children. Although I think it only really matters for the collisions here. But, you know, actually, on second thought, no. Because that could be weird, because some objects could have, like, your hurt box. The player could have a hurt box, for instance, like this. But, like, we might give the player a shield like this, and then the shield would have its own layer, like player shield, and that would be able to collide with, like, player bullets. And maybe the shield doesn't collide with enemies, only bullets. So that's why we're going to keep the rest of the player on the default layer and only put the hurt box on the hurt box layer. Because the player could have other stuff on different layers, too. Okay. So now we got our player. Let's do some movement here. So let's do a script. So I'm not going to bother organizing these files until we have files to organize. A mistake that I used to make a lot in not just game development, but software development in general, was I'd spend way too much time organizing stuff and like planning how I was going to organize stuff, which was a waste of time for two reasons. Number one, I would I'd spend way too much time organizing stuff that didn't really matter. But then also, I'd have to change the way stuff was organized anyway, because later on when I actually had files to organize, I'd be like, wait a minute, I have a lot of like this monster type of file here, and I don't want all this in one folder, so I don't have to like change the organization and stuff. So yeah, TLDR, just don't start organizing stuff unnecessarily. So yeah, let's just throw our script in here. We'll call this the player. Let's just call this the player. And I'm going to come back to that. But the player is going to have player movement. There we go. So, okay, let's go open that up. This shouldn't dox me. Good. Unity projects, this thing, assets. No, wait. Actually, I'm only interested in this scripts folder. Here we go. Although, wait, hold on. I think if I actually do this folder here, I think Unity has some like, yeah, let's do this folder actually. Because I think Unity has some built-in stuff it can do with Visual Studio Code. Actually, wait. I think there's something I need to do. Preferences? Scripting. Wait, what if I double-click on the script? Will it... Yeah, WordPad. All right, no, that's not how to do it. Preferences. Wait, project settings? Editor? Unity. Compression, resolution, joystick source. So I think there's a way to generate project files for Visual Studio Code. And, oh, here it is, C# project generation. Additional extensions, root namespace. Streaming settings. Oh, you know what? Maybe it's like an extension thing I have to download. Okay, so this is another part of programming. You go to Google. Try not to literally die. Huh. Several other things I can't stream yet. Oh, I see. So I get, oh, that sucks. I know Maven's not here, but that sucks. Let's see. Unity, C# Visual Studio Code. Here we go. So I think there's something I need to download to get these to integrate. Install the .NET. Okay, I think I did that. We're not doing that. We're not restarting that. Install the C# extension. Done. Setup versus code. Oh, external tools. Here we go. Preferences. External tools. Script editor. Visual Studio Code. There we go. Okay. Generate project files for regenerate project files. Do I want to do? I think that's fine. Image application. Is this gonna crash if I? Okay, whatever. Okay. Let's see. So now, yeah, maybe I'll. Let's just hold on. I want Visual Studio Code to reload this folder just in case it detects the project settings. Yeah, so we got to do that so that we can use Visual Studio Code. There we go. That should be better because now hopefully Visual Studio Code will let us use the Unity stuff. So like Unity engine. What's something like Vector 2? Yeah. So now Visual Studio Code knows about Unity's types like Vector 3 and stuff and Vector 2. Okay, good. Perfect. And all right, we got to make a player movement script. So in the update method. So one cool thing that I usually like to do for shoot 'em ups is to add replay support. I'm not going to do replay support yet, but I think either at the end of this stream or in a future stream, I'll show how to, add support for recording replays. It's just a matter of, well, you know what? We can start building the support for that right now. So we can like make another script file and call it player input. And then we wait for this thing to update. So the way player input will work is we're going to have, I'm going to make a little inner class in here. Actually, let's make another class file. C#. We're going to just call this player input data. Let's call it, I want this to be the data for one frame. Input. Let's just call it frame. So every frame, we're going to make a data object. So this isn't going to be a Unity thing. We're just going to, actually, I want Unity, and I'll just keep those imports. This is going to be a struct, call it player input frame. And this is going to be, I'll comment this real quick because the name is kind of ambiguous. Thank you. So I think player input frame is a bit ambiguous. I'm going to comment it so that if I look at this a year from now, I'll know what the heck this does. Stores player one frame of player input data. And then we can have like a public. So we have to have like, there's a few different ways we can do this. Let's do this the simple way. And then later on, we can like make it more complicated. So we can have like up, boolean up. Man, I've been doing like JavaScript and TypeScript recently, where the order of this is the other way around. You do like public and then the name of variable, and then you put the like string. And yeah, I gotta get used to like the old way of ordering things, putting the type first. So we got bool up, and we're just gonna. Holy crap! How do I get rid of this stupid like? Oh well, we guys have to live with that. Down, left, right. So normally what you would do is, if you wanted to be more efficient and cool, is you'd make like an integer and call that like inputs, and then you'd have like public enum bits, input bits. Actually, I guess since I'm doing this, and then you'd have like up equals 1. Oh, I think if you call this like flags, is this still a thing in C#? Oh, probably not. All right. So we got like up equals 1. Do I need semicolons here? I think so. No, commas. And we have down equals 2. Or wait, there's an easy way to do this. 2 to the exponent of 0. 2 to the exponent of 1. Left equals 2 to the exponent of 2. Right equals 2 to the exponent of 3. What do we got? Fire equals 2 to the exponent of 4. There we go. So we got 5 different button inputs, I guess. And then what you would do is, forget about this. Well, then we don't even need a struct for this anymore. So, let's see. Where do we put Unity over here? So then we can go like player input, and the way this will work is we'll have a private int. Call this a input bits. I'm gonna call this current input bits. What's the naming convention here? I think I want lowercase first and then camel case everything else. This coding stuff is beyond me. Yeah, this is I guess you don't have to do it this way. Oh, you know what? Let me do it the simple way then. Because the whole bit mask thing is pretty complicated, and we don't really need to do that. We can just do it the simple way then. So yeah, forget this. Let's do it the simple way. Public bool up. And we're just gonna have a bunch of these for which buttons you're pressing. Actually, we only need 5. Up, down, left, right, and fire. And we're gonna get rid of these. Actually, I guess we need pause as well, but we'll implement that later. So there we go. No pausing allowed. So the way we're going to do this is player input on every. Oh, okay, we're going to have a thing here. Private player input frame. Current inputs, and then we'll have like private player input frame previous inputs. And so the way this will work is that if I press the up key, then current inputs, so like this dot current inputs dot up. So if I press the up key, we will set this to true, which actually, let me just program right now. I need to do the inputs in Unity first though. So we get edit, project settings, I think it is, input manager. Okay, horizontal, okay, left, right, okay. I think there's like an acceleration thing here. Sensitivity, gravity. Is this, I think I make this 1,000 and that makes it act like a button, right? Okay, I want gravity to be 1,000 too. Okay, there we go. So now, okay, left and right, that's correct. Okay. All right, I'll just leave the horizontal and vertical. Fire 1 defaults to control. I'm gonna make that Z actually. Make it Touhou style. I don't really want mouse. I want this to be a key or joystick. Oh, key or mouse button. Okay, I guess we can't do that then. All right, Fire 1. Okay, we'll just leave this as is. It's fine. We don't need all those inputs, but I don't feel like changing them right now. Let's see. What about a combination of left and right? If that happens, ooh, that's actually a good point. So one thing I can do is I can force, like if that happens, we can just say, okay, you don't get either of those, or left and up. So if you have left and up, then you would have like current inputs dot up true, and current inputs dot left would also be true. And then in the player movement, you can say we can have like private player input frame current inputs, or actually a better way to do this. Well, how would we want to do this? I guess we can actually check the axes separately. No, we can't, because if you move in that direction, interesting. Okay, well, here's what we can do. So we're gonna have a function here, public. We're gonna return a. It's a good way to represent a direction. I guess we'll use a float. Get movement direction, and that will return the direction to move in as an angle, as a floating point angle. And we can have public float. I guess we can say bool is moving. So if any direction is pressed, is moving will return true. Actually, let's make that a comment. Returns true if any direction is pressed. And this thing will returns the angle in, let's do radians, I guess, because most things are in radians, of the current direction being pressed. Okay, and we should probably specify 0 means along the x-axis, the positive x-axis, i.e. to the right. So if this thing returns an angle of 0, then, and if is moving returns true, then we know that the player is moving to the right at an angle of 0 degrees. I think in air, in like airplanes and stuff, I think they call that the heading. So the heading will be 0 degrees. Cuckoo, big brain. Okay, so let's see how this works. So first in the update method, we gotta say what's it called? Input.get axis, and then name of the axis. Horizontal. And we can say float h equals that. I guess we'll make it, I'll make the variable names descriptive. Descriptive. And then we say if horizontal axis is greater than 0. Yeah. Or and then else if horizontal axis is less than 0. So this is how we're going to tell what we're pressing. So if we're pressing greater than 0, which direction is that again? Project settings, input manager, horizontal. Negative. Left is negative. Okay. So if it's a negative number, then this dot current inputs dot left equals true because we're pressing left. Oh, actually. Yeah, so this actually will prevent us. I suppose Unity would handle what happens if you press left and right at the same time, because we're not checking the two keys, we're actually just checking this axis. So if the axis is positive, they're holding the right direction. If it's negative, they're holding the left direction. But we actually have to do this a bit differently, because here we would have to say this dot current inputs dot left equals false. So an easier way to do this is to say, go here, we're going to make a function called public. Oh, wait, hold on. Can't make a function because it's a struct. Let's go here, say private function. We're going to say clear inputs. And we're going to pass it a, Actually, no, we don't need a function for that. We'll just do it up here. We'll just say this dot current inputs dot up equals false. Well, there's an easier way to do this actually. We'll do a little bit more efficient here. So instead of saying like if this is less than 0, this equals true, what we do is we can actually take this and say this dot current input dot left is equal to whether or not this is less than 0. And the way this works is that if this is less than 0, then this part of the expression evaluates to true. And that means that this is set to true, which is, yeah, if you're pressing the negative direction, it's going to go left. Let me see which way my avatar is moving, left. And then similarly, if you're pressing in the positive direction, that means right will be true. This is a common trick you can do with like Boolean variables and if statements or like checks, yes, no checks. Hey, what's up, pies? Welcome to the video game making stream. So we're making a shmup right now. I'm just programming some player movement. So we get our left input, our right input, and we're gonna do this again on the vertical axis. Control D, vertical axis. Hey, I like that shortcut. Vertical. And instead, which one's which? Let's see, vertical. So negative is down and positive is up. So negative is down, positive is up. There we go. And lastly, we get the fire button. So input.get button. Which of these functions do I want? Returns true while the button is held down. Okay. We want a string. The button name is fire, I think. What's it called? Fire1. Okay. Fire1. And what does this function return? This function returns Boolean. Okay. Well, that's easy. This dot current inputs dot fire equals that. Now, so there's our, we're going to comment this. We're going to say get the current inputs. But first, store last frame's inputs. This dot previous inputs is equal to this dot current inputs. There we go. So now we know what buttons were pressed on the previous frame and what buttons are pressed now. And based on that, we can figure out like if the fire button wasn't pressed on the previous frame, but it's pressed now, then we know that we just pressed the button on this frame. Visual Studio, more like Text Studio. Yeah, this is actually Visual Studio Code, which is like way smaller than the whole Visual Studio. It's much. I like this editor a lot more. I think a lot of people use this editor. It's quite good. I use this for like web development and stuff too. It's a good editor. So okay, so there's our update. So we're gonna get the player's current inputs, and then we can have some functions like get movement direction. Okay, so we need to turn. We know what direction they're pressing right now. We need to turn that into a direction. This would probably be a bit easier if I was just working with these floating point numbers here. But the reason I want to store stuff in this variable here is because you can actually save a replay by saving the contents of this variable every single frame. And then when you play the replay back, you just, instead of doing this code where you check the player's inputs, you just get the value from the replay file and say current inputs equals replay file, whatever. And that's how you do replays. So that's why I'm doing it this way. Get movement direction. What's the best way to do this? I could just make this an if statement. I'll just make an if statement, I guess. If, let's see. Wonder, I might make constants. No, I won't over optimize this yet. So this dot current inputs dot. Let's see. Okay, if the angle 0, I want to be right. So if that's being pressed. Okay, if you're pressing right, you could also be pressing up. Else, if dot current inputs dot down, you could be pressing down. Else, I guess in this case, if you pressed up and down at the same time, then it would only register the up input. So if you're pressing up and right, then we want return. I guess we don't actually need an if then an else statement if we're doing a return. We can just ignore that actually. Return. So I need a vector going in the upright direction. That's length 1. Vector 2 dot. Let's see. I want to like pre-compute this stuff. So let's see. Yeah, let's just make. I think I can just make these constants. Private constant vector float. It's an angle. Oh no, wait, never mind. I'm not making the vector. I'm making the angle. So this angle is 45 degrees, which is, what is that? Pi over 2 is 90 degrees, so it'd be math dot pi divided by 4. There we go. Yeah. So math dot pi is 180 degrees, and so math dot pi divided by 4 is 45 degrees. Okay. And if you're pressing up, right, and down, then you're at, you know what? We should probably say returns a value between negative pi and positive pi. There we go. So we will return negative math.pi over 4, and if you're holding just right, we return 0. Let's see. Else. Oh, I don't need an else, really. Yeah, I can get rid of these else's, because the return statement just breaks the whatever. Anyway, let's see. Wow, working on a demo scene for it already. How's the new place been? New place has been really nice. I've basically got my own room, although it's in a basement, so it's below other people, so I can't be too loud in about an hour. I'll have to be more quiet. Let's see. Yeah, it's great. Thanks for asking. How are you doing, Pies? Okay, so we got, if we're holding current inputs down left, and now we kind of do the same dealie, so let's copy and paste this here. If you're holding up, then up and left is this direction. That's like 3/4 of pi. So 3 times pi divided by 4, and this is negative 3 times pi divided by 4, and this is just math.pi. Okay, and if you're not holding left or right, you might be holding up or down. So then we do these. So if you're holding up on its own, that's pi over 2, and if you're holding down on its own, that's negative pi over 2. And if you're not holding any direction, we'll just return 0. Because in theory, this function won't be called if you're not holding any direction, so is moving. Is moving is true if this dot current inputs dot up, or this dot current inputs, dot current inputs dot down, or this dot current inputs dot left, or this dot current inputs dot right. So yeah, if any of these 4 variables is true, then you're moving. And then we can finally have public bool is firing. And then return this dot current inputs dot fire. So we're not actually using the previous inputs right now, but I'll keep, well, I guess if we're not using the previous inputs, I should delete it. Let's get rid of it. There we go. Okay. Nice. So now this class handles player input. And the reason, again, I separated this out from player movement is so that if I want to make a replay, actually I can write that here. Handles player movement can accept input. In the future, this class will be able to accept inputs from a replay file. There we go. Okay, yeah, so that's why this class exists. In the future, this class will be able to accept inputs from a replay file. So yeah. Let's see, I had my first real stream a couple days ago. Oh, that's interesting. I didn't know you streamed Pies. Huh. Touhou, yeah, I like this song. I think it's fitting that I have Touhou music for a shmup stream. It was going to be a Discord stream. Ah, ended up doing it on Twitch. Oh, I see. It was nice to see everything was working. Nice. Now I want to finish my live to the app. Oh, wow, I've actually never seen your avatar, Pies. Yeah, Pies the VTuber. Yo, I want to see Pies the VTuber, but maybe we gotta wait. Maybe it's a secret for now. That sounds awesome though. Definitely let me know. Am I following you, Pies? Let's see. I am. Okay, so if you stream, I will know. Okay, so now that we have this class here doing our movement, and this is a behavior. So we need to go into here. Pies, have you seen this horrible thing I made for the player? So, player. So we can just stick our movement scripts and stuff on here. I'll start with this player script will do... Okay. Oh. Okay, well we can fix that. Oh, because I didn't name this player. There we go. Player input frame. Did I even end up using this? Yeah, I did. Okay. Player movement. Okay. So player movement is going to have public player input. There we go. So let's stick a player script on our player here. The player script I have plans for later. I'm just going to stick it there for now. Put a movement on here. And which one is it? This one. I'm going to put player input on you. There we go. Now it should be letting me... wait a minute. Oh, I didn't save it, that's why. Now we should see the variable show up in the inspector. There we go. You can just drag this on there. Perfect. We can actually do this automatically as well. The way we do that is in start, for instance, we can say get component of type player input, and then just say this dot input equals that. And that way we don't have to like reassign the player input at the start of the game. So yeah, you can do either of these methods. Technically it's like slightly slower to get every component when your game starts, but in practice no one's going to notice if it takes like an extra 2 milliseconds or whatever to get the components when the game starts. And I mean, I don't even know. So, but whatever. I guess we'll do it the simple way for now. So we just drag that onto there and we got player input. Its name is Raymu. Oh, interesting. There's not too many assets. I'd be more like when they make stuff. Cool. Yeah, honestly, if you want to make like anything, just like send it my way, I guess. You can send it over Discord or put it on like Dropbox or anything, or Google Drive, and yeah, just let me know. Because as you can see, I mean, I spent like what? A few minutes making this. Like, it's not going to be a huge loss if I replace Mr. Ugly Face with like an actual looking sprite, like a Mahou Shoujo or something, or a Touhou character. That would be pretty awesome. I was thinking of like making this a pixel thing, but then I decided not to because I didn't want to spend any more time on it. Okay, so our player now has movement. Well, wait, we need to actually make the movement do something. So on the update, we're gonna say, it's a bit of an issue here. We need the player input to do its update before player movement. So what I'm actually gonna do is I'm not gonna, I don't actually want this to be a mono behavior. It doesn't have to be anyway. You know what? This is not going to be a mono behavior. And what we're going to do is, instead of this variable, we're going to make it private. And when the game starts, when the scene starts, we're just going to say this dot input equals new player input. Boom. And then we can do updates and stuff. So here, instead of update, let's call it something different. We're going to say get current input. or let's call it get next inputs. Let's just say get. Let's say next frame. Okay. Public. Okay. So actually, let's see. Let's say call this process next frame. Process inputs for next frame. And now it just does what it says on the label. And instead of start, we're going to make this the constructor, I guess. Oh, wait, this isn't doing anything. That was just me demonstrating stuff. All right, there we go. So I'm going to say, oh, shoot, what's happening? There we go. Oops. I really hate this stupid zero references thing, but I don't want to take the time to change that in my preferences right now. I'm going to say called once per update gets processes the inputs for the next one. Okay, example from the player or from a replay file. Let's actually call this update inputs for next frame, not process. Updates the current frame. Whatever. Anyway, so there's our comment. Ooh. Called once per update. Speaking of called once per update, let's actually do that. So we're going to say this dot input dot update inputs for the next frame. And after we do that, we can say this dot inputs input dot get movement direction. And we can say float movement angle. Oh, wait. Before we do that, we need to say if this dot input dot is moving. First we check that, and if we're moving, then we're going to say this dot input dot get movement direction. Well, first we need a vector2. We're going to call this a movement vector equals new. I need to make a vector from an angle and a float. I don't remember if this thing has a hold on. Did I use mathf or math? Okay, good. Because mathf is the floating point math that Unity provides. Let's see, what would you like the player to be? That would be pretty cool. Yeah. I don't have any idea what I want the player to be, so just do whatever you want. I think a 16x16 player would be cool. The only thing that I think is important, let's see, I need to make the resolution smaller. It's okay. I can actually, there's a thing here when I import a sprite where I can tell it how many pixels are 1 unit in game. So right now it's just 1:1. 1 pixel of the sprite is 1 unit in game. But if you make pixel art, I can make this like, what's 1 divided by 8? Like 0.125. And then each pixel, if I import this is gonna get 8 times bigger, like this. So now every pixel in the image file takes up 8 pixels on my screen. So yeah, so we can just do that then. So yeah, you can just send me literally a 16x16 PNG, and then I can use this value here to scale it up to whatever size we want. And we can use, then I would change this to point filtering and so on. So yeah, pixel art is pretty easy to import. In fact, that would be a neat little tutorial thing too, to show how to use pixel art in Unity. Okay, so let's see. Okay, does this thing have a function to make a vector? I think I have to write this function myself if I recall correctly. Angle clamp. Is there really no thing to make a vector from an angle? I guess I have to do this myself. I swear there was a function to do it though. That's a half. Oh, that's interesting. All right. Let's make a. Hold on. Let's make a utility script here. Oh, whoops. Hold on. Player input doesn't exist anymore. Let's remove this script. There we go. New util script. Util. Okay. Util is not going to be a Unity behavior. It's just a class. And we're going to say public And actually, this is going to be a static class, which means we're not going to make any instances of util. We're just going to make static methods like vector2, say from, what do you call it? Magnitude and angle. Okay. And then we have float magnitude, float angle. Okay. And this is going to return new vector2. So the x coordinate is going to be magnitude times mathf dot, I believe it's cosine for the x coordinate of angle. And this takes the input in radians, perfect. And then the y direction is magnitude times math dot sine of the angle. So this is where math is really, well, at least like high school and maybe first year trigonometry is high school, right? So high school math is really important in games development. Know your trigonometry. There's actually like college and university courses on graphics, but you don't really need those, I don't think. You just need to know how to do a vector from a magnitude and an angle. And it's just this. X is cosine, Y is sine. Is your chance to put yourself in a game? That's true. You can send me PNGs and I'll put you in the game. But the restriction is that the stuff you send me has to be Creative Commons so I can release it. That's the only restriction. So I guess you wouldn't want to send yourself unless you want your picture of yourself to be Creative Commons. Okay, wow, I've been doing this for an hour? Dang. All right. Oh, we have a Discord message. Wait, what is... Oh, it's that. Never mind. Ignore. Okay, so... Where's OBS? Okay, so... Right, now I have my util. We're going to say, if we're moving, then vector2 movement equals... Well, actually, I kind of need that. No, I don't. 2 movement equals util dot from magnitude angle. I thought I named that differently. That's fine. Wait, we need a variable for your speed. So I'm going to say public. Everything you make public is going to show up in Unity. So make a public float speed. Default to, I don't know, 10 pixels per second, I guess. Hold on. Float magnitude equals. So we actually... So here's the thing. To make this speed like 10 pixels per second, we actually have to take this dot speed and scale it by time dot scale, I think it is. Time scale. Here we go. So for instance, if our game is running at 60 frames per second, time.timescale will return 1 divided by 60. And that will multiply our speed. And that's how you get this speed to be, instead of pixels per frame, to make it pixels per second, which is a lot easier to think of conceptually. So yeah, I think 10 pixels per second is a pretty good speed. So now we're going to take magnitude, and for the angle is going to be this dot input dot get movement direction. Okay, in radians. Okay, and then once we have a movement vector, we're going to say, we're going to need, hold on, private transform. Actually, no, wait, this thing is on the transform. Actually, I think it's, I think I want the rigid body. Hold on. Private rigid body 2D RB. I think RB. Yeah, we can just call it RB. And then at the start of the game, we're going to do this dot RB equals get component rigid body 2D. Okay, there we go. So our this dot rigid body dot let's see, how do I do this again in kinematic mode? Is it apply force? Add force, add force. I'm pretty sure it's add force. I'm gonna have to experiment here, I think. Add force. Hold on. Unity rigid body 2D move pixels. This one? Blah 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 blah. Okay, no, that's not helping. Screw it. Let's just look at the API. Make it. I think I'm on 2001. Move the rigid body to position. Let's see. Blah 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 blah. Okay. Blah 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 blah. Confused with kinematic rigid bodies. Okay. Yep. Ours is kinematic because we're moving it with arrow keys and not physics. I don't think move position is the one that I want though. Is it add force? Relative to its coordinate system. Add torque. I think I want add force. This force is okay. Okay, but I believe I don't need to have mass. Okay, the default is, which I'll be using mass. Force mode 2D. Okay, there are two types of forces, force mode, impulse mode. I believe impulse mode is what I want. To just apply the force with no mass. Use impulse mode as a force. Doesn't actually say what it does. Here it is, add an instant force impulse to the rigid body using its mass. I think I want this. Well, we're gonna find out, I guess. Let's see what happens. Dot apply add force. So I think was it take a vector? Yep. We have movement and force mode 2D dot impulse. All right, so let's see what this happens. In theory, we should be moving at 10 pixels per second. What's this? I don't think that matters. All right, so we're gonna run the game. Oh, whoops, I forgot to give our player. Whoops, you know what? This rigid body should actually be on the player, not on here. So, whoop, my bad. Physics 2D rigid body. Here we go. Just put it up there. So, get rid of this one. Move. Kinematic. Okay, simulated. Okay, that should do it. Clear our errors. All right, now let's do some debugging. First thing we're gonna do is, let's see if we even get here. How do I log stuff again? Logger dot debug dot log movement. And I'm gonna put this so I remember that that's a temporary line of code. And let's see what we get. So if I press right, okay, that is correct. My direction is 10 to the right, and if I press left, it should be negative 10. Yep, left is negative 10, okay. Up is 0 and 10, okay, so it's working. Down is 0 and negative 10, that's correct. It's just not moving. Maybe I'm supposed to do move position for a kinematic object. Okay, I think actually that's what I'm supposed to do. So, rigid body, kinematic, what's kinematic, physics control. This should tell me what to do, right? This can be useful. Should be controlled kinematically, non-physically, but then sometimes needs physics for realism. Human character is usually not implemented using physics, but may sometimes be thrown in the air and collide with objects as using physics. So API is not as useful as I was hoping. But okay, so instead of add force, we're gonna say dot move position. What's the arguments for that? The new position of the thing. So this dot transform dot position plus this dot movement plus movement. There we go. What? Oh, son of a. Hold on. Public static vector 2 from 3. I don't know. 3 v3 v, I guess. Return vector vx vy. There we go. I think actually, does the vector2 constructor do that? 2 dot. This dot transform dot position dot. Can I get a vector2 out of this? No. All right, whatever. We made a util method now, so now we can get a vector from. I guess these methods should be capital, first letter capital, and go from what? Rename it capital F. There we go. And this will be vector2 dot from vector3. This is your chance to put yourself in a game. You go, this isn't right. Yeah. Okay, essentially the first batch of assets, the main character with, whoa, animations. Oh, baby. All right, cool. So if I get around to animations, we'll have animations. Nice. And a pellet to shoot. Oh, wicked. Okay, once I get this movement working, I'll add them in. And some big, tiles. Oh, background tiles. Whoa, cool. Ooh, interesting. I might be able to show off the tile map. Animations. Yeah, I guess I can show that off though. So let's get this movement working first. So vector3, okay, make a 2 from a 3. So util dot from a 3. There we go. That's a little bit of a confusing name though. Let me... I don't like this name though, util dot from magnitude angle. What I kind of want to do is rename this from like util to like v2. Yeah, sure, that'll work. So now it'll say like v2 from magnitude angle, v2 from v3. Oh, hold on, we need to do rename symbol so it renames it. There we go. That'll be make a little bit more sense. So we can okay. Yes, now it says vector2 dot from magnitude angle, vector2 from vector3. Okay, there. Now you get a better idea of what these weird functions are doing. So now in Unity, let me just rename this to v2. Okay. And if we start the game, and I press right, hey, there we go. So 1,000, 1,000. Does it feel like it's moving 10 pixels per second? 1,000. It feels like it's moving way faster than that. Let's see. Hang on. Feels like it's moving a lot faster than that. Yeah, let's put our player down here. Make this like minus. So if this height is 720, let's put like half of that is 360, so maybe like 320. Oh, whoops, hold on. This is the wrong. I think I want this to be half that, 360. Yeah. So then this will be positive 360, negative 360. There we go, yeah. Okay. Also here, I want this game to run in 16:9. There we go. Okay, there we go. This is a lot faster than 10 pixels per second. Also, why does it keep moving up even when I let go of the button? Oh, I know why. I forgot to change those inputs. Project settings, input manager. Yeah, I forgot to change these so it acts like an instantaneous button. There we go. No more acceleration. Because horizontal is already like that. Okay. Good, good, good. Oh, WASP is actually programmed to work too. Let's see. As much as I could get in the 16:16 with 4 colors. This feels like it's moving faster than 10 pixels per second. Black outlines is no color. Having a pixel character should help with knowing how many pixels per second is moving at. That's true. Well, in theory, this should be 1,280 pixels across. 2, 1,000, 3, 1,000. Move that in about 3 seconds. Suspicious. Where's my calculator? Did I close my calculator? God damn it. Okay, I have a scene for this. It's this. Let's get my calculator up. We go back to the other scene. There we go. So that was 80 pixels in about 3 seconds. It's moving about that many pixels per second, which means per frame it's going about 7. So I feel like I messed up. I don't think it's scaling it correctly. Hold on. Yeah, speed 10. Magnitude equals speed time dot time scale. Oh, whoops, wrong. Oops. Wrong one. Delta time is the one I want. Yeah, the completion time in seconds since the last frame. There we go. I think that's delta time, I believe, is what I wanted, not time scale, because time scale is just equal to 1. We're very slowly moving. Maybe time scale is not. Maybe delta time is. I'm pretty sure it's delta time. Fixed delta, yeah. Moves the rigid body to position. This is weird. That's weird. Why is it so slow? Actually, maybe that makes sense. Let me check something. Let's make the speed 720. This should let me move up the entire vertical length of the screen in 1 second. 1/1000. That was definitely not. That's definitely not 1,000, 2, 1,000, 3, 1,000, 4, 1,000. Why is this going so slowly? Let me check something. Let me check this thing. Time. Time to check the API. Man, it's been a while since I made a game in Unity. Can you tell? I'm pretty sure I'm supposed to use delta time. To move a gamed object in the y direction at n units per second, multiply n by... Yeah. That's what I did. Something is weird then. Move to position. Weird. Let's check here. Let's see what this thing was. Debug.log movement. Let me make sure my vector makes sense. So I should know how big that vector should be. It should be 720 divided by 1/60 of a second. It should be 12. Let's see. Console. If I press right. Why is it different? Why is it like 1/10 the size it should be? 1.2 instead of like 12. It's also changing. Hold on. Graphics. I think there's something where I have to like fix the frame rate. So I really only want this to run at 60 frames per second. That might actually be messing it up. The fact that it's running at a weird frame rate. Time dot. Let's see. I know there's, let's see, frames that have passed. Smooth delta time. That's interesting. Maybe I should actually use that instead. Huh. Man, it's been a while since I've used Unity. Let's see. Fixed frame rate. Oh, it's application.target frame rate. That's interesting. Interesting. Okay. So this will make my replay a little bit difficult to make because replays require something to run at exactly 60 frames per second. Target frame rate. All right, let's just stick this in. I thought there was a way to set that in the settings. I forgot. Okay, we're gonna have a game object here called like global. I don't know what to call it. Yeah. Well, maybe just like, yeah, I don't know. Maybe call it the stage. And then this thing can like take care of all the stage related stuff. Like, we have a script here. Call this stage. And so the first thing the stage is going to do is it's going to say application.target frame rate equals 60. Okay. I wonder if that's actually going to fix it. Doesn't seem to have fixed it. Why is it so small? How is that possible? So I'm using 720 and I'm getting that result. So divided by like 8. Why is it running at 90 frames per second? Let's see. How do people do this stuff before Google? I have no idea. But like nowadays, not just for game development, for software development in general, you Google all kinds of stuff. A lot of reading of manuals too. Yeah, I'm glad we're not in those times. But damn, why is it not? Okay, this is. What am I missing here? Time.delta time. Let me check something. So we're gonna say debug.log this .speed, because I mean that shouldn't change. Debug.log magnitude. There. It's possible. Maybe I messed something else up. Oh, we're gonna find out, I guess. This is how we debug. We put in about a bunch of log statements and see where things are weird. Okay. All right, let's go to the bottom. So speed is 720, but then magnitude is 1.1. Why the hell is it getting rounded? Hold on. That's weird. Hold on. Why is it getting rounded? Magnitude angle. Float. Vector 2. These are all floats. Sign of angle. Something is weird. So, okay, first of all, why is this only 1? Why is it getting divided by a 720? What in the dickens? Why though? But oh, whoops. Oh, whoops. I know what happened. Stage. I forgot to put the stage in the scene. That's why it's being weird. So I didn't actually set the target frame rate. Here we go. I think I did this, but it was still in running the game mode, which is why it didn't happen. Okay. Right. There we go. Correct. So 720 divided by 60 is 12. So that is correct. There we go. Now we're moving 10. Now we're moving. So now we should be able to move in 1 second from the bottom to the top. 1,000. Looks legit. All right, there we go. So that's interesting that when the frame rate was really low, I was getting really small numbers, and apparently that like messed it up somehow. Interesting. I'm not really sure why it was like so much slower. Like, because in theory, if the frame rate is faster, then this should have, yeah, I don't know why it was weird like that, but whatever, it works now. Okay. All right. So yeah, so now we have our moving person. So where's the debug menu that gives you infinite lives? Let's see. A pellet, they probably, yeah. All the pellets are pretty dubious, really. Huh. Gotta have those deltas. Yeah, okay. All right, so it's taken me an hour and 20 minutes, but I can move a face. But you know, we're making progress. Now we're gonna replace the face with something better. Let's see what we got from pies. Ooh, cool. Let me see this little duty. Oh my gosh, he's so tiny. Let's see, save image as documents, Unity projects, this thing, assets, textures, assets 1v1. Sure. And then we also got this thing here. Okay. Save image as. Can't remember the folder. Yes. Okay. And if I go back to Unity, it will import these automatically. I'm gonna sneeze again. I'm gonna hydrate. Okay, let's see what we got. Interesting. Okay, who do I want to use for the player? What's this called? Assets enemy. Gotcha. So this is what we do. This is not a sprite mode. This is multiple sprites. Pixels per unit. I don't know. I'll just put like 0.125. So each pixel is 8 by 8, I guess. And maybe I'll make that like bigger later. Physics shape. No, I'm planning to use my own hitboxes. Thank you. Filter mode point so that we get pixelated graphics. Sprite editor. Oh yeah. Hey, here we go. So I believe I can actually just like make my own sprites like this. Cool. Oh, is this Pies? Who is this? Oops. Let me fix that. Who is this sprite, by the way? Pies, is this you? Oops. Square should work, please. It's supposed to be me. Oh, cool. This is really cool, actually. Wow. Okay, who's? Oops. No, don't. I'm not supposed to touch that. Okay. 0.5. Okay, touch this. Oh, no. Okay. So maybe like that, and then there we go. And we can have it like 1 extra pixel margin, I guess, around the edges, because the edges of text tiles usually mess up a bit. Actually, is that going to overlap? Oh, never mind. We can't do that because it'll overlap the other sprite if there's a rounding error. So we got to make it tight around the sprite. There we go. All right, this will be. What's the difference between these two sprites? Well, we'll use this one. Ooh, a pellet. I see. Okay, we're gonna call this one normal. Okay, apply. And then how do I make another sprite? Custom outline, custom physics shapes. Type. Nope. Oh, I think I just draw another sprite on here. So let's get one for the pellet. There we go. Pellet. A custom pivot. Center. Oh, just make the center dirt. There we go. All right, there's our sprites. So now we have this guy and this pellet. Hey, wait, why is it weird? Hold on. Sprite editor. What? I told you to do this. No, what? There. Okay, weird. Apply. Apparently grabbing those green things doesn't do what I thought it did. Okay. Now our pellet, yep. Okay. So let's take the ugly, Mr. Ugly here. Gonna swap this out with this. And hey, perfect. It just works. Yep, so each pixel takes up 8 pixels on screen, and we can still move around. Cool. All right, look at that. We got Kukushie in game. Pokemon Crystal version. 16 by 16 thing has 1 pixel, nothing on the side. That's good. Yeah. As low as the down sprite. Oh, cool. All right. Well, let's do this for now. Okay, well, we got our player character. Now we need to fire some pellets. So let's make an object here. Call this player bullet. You know what? Let's call it this. Let's make bullets just the enemy. Let's I don't know. Player shot. And we're gonna put this in the middle. Give it a sprite. Oops. 2D object sprite. Sprite. As opposed to 7-Up. And we're gonna take this pellet here and stick it on there. There we go. Oh, that's a nice big old pellet. I think I'll just leave that as is. This thing's gonna be the hitbox. Okay, a player shot is gonna need a rigid body. Again. Here we go. Simulated kinematic. Okay. Collision detection. Okay. Start awake. Okay. I feel like the shots might travel so fast that I want continuous detection. But I'll leave it like this for now. Cuckoo, more like Zune number 2. Like Zunku. Or Kuzun. I don't know. Okay, hitbox. Let's give this a box collider 2D. Bop. And how big are we going to make this? Like 2 by 2? Why can't I see that? Oh, wait. Because it's times 8. So 2 times 8 is actually 16. There we go. Well, let's make it this twice that big. 32 by 32. There we go. Cool. Okay, looks good. Oh, excuse me. Bullet needs movement too. So let's make a really simple script for this. We're gonna call this bullet. Let's just call this projectile movement. There we go. And this is gonna do what you think it's gonna do. Projectile movement. So you give it public. I guess it would have a speed. What? Oh, whoops. Public float speed. And public float angle. And then all it's going to do is on every update, it will just move by that amount. So we can like take this code here basically and stick it here. So magnitude equals this dot speed dot delta time. Angle we already have. Movement equals magnitude and angle. And then this dot, oh, we need the rigid body. Whoops. So let's copy and paste this as well. Bop here. Bop here. So these stupid reference things are so annoying. Like, why are they taking up my, my space? There we go. Okay, that should do it. And now we should have player shot. I'm gonna stick our projectile movement on here. Here it is. Bop. Speed. Let's say an angle of 0. Sure. This thing's gonna go fast. I feel like excuse me. I feel like this. So it should move really fast in the right direction. There it goes. It's pretty slow for a player shot though. Maybe you make it angle's gonna be. This is in radians. Oh, hold on. Well, this is fine. Because I'm not actually going to use these variables here. What I'm going to do is, okay, the player needs, we need something to fire stuff. So we're going to host the player gun. And this is going to do pretty much what you expect. Let's see, player gun. So we're going to have a public game object shot prefab. So what we're going to do is, I guess we'll say public float. I guess we'll see public float angle degrees. Okay, so what we're gonna do is so rather than using the update, we're gonna rely on player movement. which is maybe a little bit jank of a way to set things up, but we're not too worried about that right now. Public void fire. Okay. And you know what? Let's have the gun have a cooldown built in. So let's call this shot angle. And we're gonna have public float cooldown. Okay. And we're gonna have private float next shot time. Or let's call it cooldown end time. There we go. That's gonna tell us when we reach cooldown end time, we can shoot again. So public void fire, we're gonna say exactly what this does. Fires a shot if the cooldown has ended. Cooldown from the previous shot has ended. Cooldown end time, we can actually just make 0. Because the game starts at time 0, and you're not gonna be in cooldown from the shot. So the way this will work is if this dot cooldown end time, if it ended by the current time, then we can actually, well, let's do it the other way around. We're gonna say if it cools down in the future, then just don't do anything. Cooldown ends in the future. Okay, so do nothing. Okay, and then here we're gonna fire shot. So what we do is we take the shot prefab. What is it? I think it's like instantiate game object. I mean, I don't think I need to do that. Let's do instantiate. Oh, yeah, I do. Game object. This dot shot prefab. What are the arguments for this again? Position. I guess I'll put it at my current position. Transform dot position. We don't need a rotation. Does that work? Wait. Okay. Okay, never mind. So let's just instantiate this, and then we can say, oh, I need the object. Game object shot equals that. So we're gonna make a copy of the prefab, and that'll be our shot. Let's see, Kuzukun. I don't know if Unity does filtering for files automatically, but if it does, you should try to disable it now. You mean like bilinear filtering? Yeah. So there's actually an option on the texture. That's this option here, filter mode, and I've put it on point filtering, aka no filtering. So yep, we're good. The pixels, oh, this one's not good. 0.125, there we go. Apply. There, so our sprite graphics don't have any filtering, whereas like if I change this to bilinear, yeah. There we go. Let's see, the pellets are a bit less than 8x8. Oh, yeah, this is, yeah, it's already like starting to get cool, eh? Okay, let me make the pellet smaller then. Well, I'll shrink the pellet in here then. So sprite. I think I just shrink it here. Scale it by 0.5. There we go. Now our pellet is 4x4 instead of 8x8. Although it's kind of weird because the pixels here are smaller than the pixels on me. Unless I make me smaller too. So we could just change this to like 0.25. 4 pixels per pixel. There we go. Maybe that makes more sense too, because your player character is usually not that big. Those emotes would be perfect, but I don't have them. Oh, I like that emote. Hype. It's kind of small to see on stream, but when I mouse over it, yeah, I like it. Okay, so what we need to do is take this shot thing. You know what? We're gonna need. I think we're gonna need a script to do like called player shot, and later on I'm gonna need this script to do some stuff for me. So let's stick it on here. Well, put it up here, I guess, or not. Can I not move these? There it is. Okay. Okay, looks good. So now we're gonna make another folder in our assets, call it prefabs, and we'll stick player shot and make it a prefab. There we go. So now we can take this thing and make new copies of it later on. So we don't need this anymore. And then, where's our player? We need to put the gun script on the player. I'm actually gonna make a child object here, call it the gun. And that way I can choose where the bullets appear. So right now, instead of, wait a minute, something seems off. Oh, that's why. Hold on. There we go. I want my sprite centered at my player. There we go. Oh, that's convenient. The hitbox is actually right where the neck is. Perfect. Very Touhou-like. Okay, so our gun, we're going to move this up a bit so that shot bullets appear at our head. Maybe like here. We should make it a multiple of 4 because the sprites are all multiples of 4. There we go. Okay, and we're going to put the gun script on here. And then we're going to come here. So we're going to tell the movement script where our gun script is. Where is it? Public, float speed, public, player, gun, gun. And what we're going to do is over here. So we're going to say this is do movement. And do firing if this dot input dot is firing. This dot gun dot fire. There we go. Nice and simple. So whenever you hold down the fire button, our gun is going to try to fire. Or it'll try to fire anyway, if it can. So let's see. So then back over here in Unity, our player movement now has a gun. And we can take the gun and drag it onto there. There we go. And the gun is going to have... Where is it? Instead of game object, we're going to call this player shot. So we'll clone that. There we go. No, do that. And then here we're going to say shot.transform.position. Actually, we should move the rigid body. No, let's just do this. Position equals this dot transform dot position. So the shots will appear from wherever the gun is, and that's why the gun is a separate object from the player. So we can just move the gun wherever we want. And we're going to say shot dot speed. Oh, wait. I actually need this needs to be a projectile movement actually. Okay. Well, there's a few different ways I can do this actually. You know what? I'm actually going to take the movement stuff here and put that onto the shot. So I'm actually going to take this. I mean, I can leave it here for now. Say a shot. I'm just going to stick it in here. There we go. That'll simplify things. So then shot dot speed equals this dot shot. Well, we don't need to change that. Shot dot angle is going to be this dot shot angle in degrees. Oh wait, but this is degrees, so we need to multiply by f dot degrees to radians. There we go. So now I can set the shot angle in degrees, which is easy to work with, and it'll automatically get changed to radians whenever I fire the actual shot. So we create the shot at our position, and we give it the angle that we're shooting at, and it's got its own speed, so that's good. Oh yeah, and then we need to say this dot cooldown end time equals this dot. So the current time, time dot time, and then we add the cooldown amount. There we go. And that'll tell us when our cooldown's going to end. Okay. That's good. So like you might think of cooldowns as like counting down in other games. Well, the way we're going to do cooldown here is we're just going to remember when the cooldown ends. And once the time catches up to that point, cooldown ends, rather than having like a countdown timer. Okay. So, the bullets aren't going to self-destruct after they go off screen, but that's fine for now. In fact, we can go off screen too. That's fine. What's my fire key, Zed? Oops. I forgot to actually set up the shot here. So our prefabs, player shot, there we go. Shot angle in degrees, 90 degrees. Cooldown. Oh god, we need to give it a cooldown. Maybe like 0.1 seconds. So we can fire 10 times a second. Let's try that. Oh, I disappeared. There we go. Okay, well, the bullets aren't moving, but we can fire them. That's good. Oh, I didn't give them a speed. That's why. Okay. Oh, let's remove this actually. There we go. Speed. I don't know, 1,000. See how fast that is. There we go. Okay. Yeah. All right, we can fire. 1,000 feels a little bit slow though. You want to make it 2,000. which means I'm actually gonna take the collision here and make it continuous so that we can't like accidentally go through any enemy sprites, any hitboxes by accident. Let's see. What have you brought to this chat? How far were you planning on going with this game? You just made a nifty drawing program. I want to at least get like a boss up and then fight the boss. So I'm gonna have to hurry up because I'm gonna have to start being quiet soon. Okay, so I'll practice being quiet now a little bit, I think. Actually, let me switch my microphone preset thing to quiet mode. There we go. Okay, perfect. There. That should be a little bit louder now. So now we have our player. We can shoot. We need to do an out of bounds check. Okay, I feel like I want to make a script for that. So I'm just going to have a script here. I'm going to call this destroy out of bounds. Okay. And then anything that goes out of bounds of the screen will just get destroyed. Okay, so we'll put this on the, where's our prefab here? So scripts destroy out of bounds will stick on here. So we don't want it to destroy when the center point goes out of bounds. We want it to destroy. There's a few different ways I could do this actually. I could put colliders at the like out of bounds, and then anything that hits the colliders just disappears. I wonder if that's better actually. Probably not. No. Okay. So public float size. Call it size equals whatever. So then check. Let's see. The comment for this class is going to be destroys this game object when it goes out of bounds. And the size of this object, it won't be destroyed until the entire object is out of bounds. And by size, I'm going to mean radius. In fact, let's just call it radius. The radius size in brackets. Okay. Because radius is easy to understand as like half the diameter of a circle. So let's see. So check if we're out of bounds. If how do I know how big this thing is? I think I'm gonna need to update the stage here to static class. Let's make a function on the stage and call, oops, hold on. Not a static class. We're gonna make a function on the stage and we'll call it public static is out of bounds. And then you can give it pass it a vector 3, I guess, position, and pass it a radius. And say is object out of bounds. Okay, and it returns true if an object at a position with a radius is completely off screen and out of bounds. Let's say out of bounds, i.e. off screen. There we go. So we're gonna say, there might be a fast way to do this, but let's just do this the simple way. So first I need to actually know how big the stage is. Singleton class representing a stage where gameplay happens. And we're gonna say public static stage instance null. And then on awake. So what a singleton does is that there's going to be one instance of this class somewhere. Stage dot instance equals this. Okay. You know what? Let's also set the target frame rate in awake because I want that to happen ASAP. Okay. So we're gonna have public float width, I guess. Public float height. All these stage dimensions. Yeah, okay. let's see. So the width is probably always going to be 1280, and the height is going to be 720. So if position dot x, you know what? Most things are probably going to leave the stage on the top and bottom first. So I guess it's a little bit more efficient to do this. So if you're above, something is, oh, okay, instance dot height, hang on, float half height equals instance dot height times 0.5 and half width. So if the height of the stage is 720 pixels, you know what? Maybe I should actually, maybe I should put the 0 point in the lower left corner. That might make this, that would actually make this easier to do. Hold on, let's do that. Okay, so the camera is actually going to be positioned at, what's 1280 divided by 2 is 640 and 360. And now the player is going to be at, I don't know, 32 pixels up. So I get like 64 pixels up. And in the middle, which is 360, or no, 640. That might be easier to understand. So now 0 is here. Yeah, I feel like that'll be a bit easier to work with. Okay. Now we just say if position dot y is less than 0, or not 0, negative radius, there we go. Or actually return. So return tree if that's true, or position dot x is less than negative radius, or position dot y is greater than instance dot height plus radius, or position dot x is greater than instance dot width plus radius. There we go. We're going to say assumes 0, 0 is the lower left corner of the visible area. There we go. Okay. So we got our stage with our width and height. This thing here is just on every frame. We'll check if stage.inst is object out of bounds. This dot transform dot position. This dot radius. Okay, if we're out of bounds, this dot game object. What is it? I think it's just destroy this dot game object. There we go. That's it. So anything that we stick this script on will destroy itself automatically once it goes out of bounds. And this is, if you want to learn Unity, this is, I think this is a good way to do things, is you have a script like this that just does that one thing. Like rather than saying, oh, well, the player shot should destroy itself out of bounds, so I'm going to edit the player shot class to add that logic. It's easier to say, I'll make a script that destroys things that go out of bounds, and I'll slap it on the player shot, and boom, there we go. Now you can see, yeah, it's just better to have a reusable component like that, because we can slap this baby onto the enemy projectiles as well, and we could even slap it on the enemies, but I don't think that's a good idea, because they kind of have to be out of bounds to show up. But there's some things we can do to use that. Are you thinking of giving the boss multiple attacks? Yes, absolutely. Okay, so now when we play and we start firing, the bullets they get destroyed when they go off. Nice. All right, this looks like a good shot speed too. All right, now we need to make ourselves not be able to go out of bounds. For that, I think I'm actually gonna code that in player movement specifically. So let's see. Hold on, there's too many files open. Player movement. Let's see. Prevent player from moving beyond the edges of the screen. So let's just do this real quick then. If see. So vector 2, 3. Hold on. New position equals. Okay, let's make this a little bit optimal just here. Position equals new vector 3. We're gonna say It's gonna have a method here. Public. Hang on. I'm gonna make another script file and call it v3. So here I'm actually maybe gonna make a folder for utility scripts like v2 and v3. Okay, v2. Create script, call it v3. Whoops. Okay. It's just gonna be like v2, except it's called v3. We're gonna have a function here, public static vector 3 add, and it's gonna take vector 3 v1 and add a vector 2 to it. Actually, can you already do this? Hold on. No, you can't. All right. Turn u vector 3 v1.x plus v2.x, v1.y plus v2.y, v3 v1.z. There we go. So now we can add a vector 3 with a vector 2. Then we can say vector 3 new position equals v3.add. This dot transform dot position. We're going to add that to movement. There we go. And the reason I'm kind of doing this is I don't want to call transform.position more than once. I just want to get it once, get my new position, and then v2 from v3, boom. Okay, then we make a vector 2 out of that, and now we can use the vector 3 new position. Wait a minute. Why did I do that? Actually, that was kind of dumb. What I actually want to do is, yeah, hold on, v2 dot from v3. Hold on, hold on. Actually, just undo. Vector 2 new position equals this stuff in here, position plus movement. And then we're gonna put that above here, move position to new position, and then we can just check. Actually, wait. Let me do the check here. And then we'll do the move. So we're gonna make sure new position is still on the screen. So if new position dot x is less than 0, or I guess we need to know how big the player is, don't we? Public float speed, public float width. How big is the player? I don't know. I'll check later. Public float height. Okay, so then we say if with this dot width, hold on. We actually we don't need the width, we need half the width, whatever. I won't optimize too much. Float half width equals this dot width times 0.5 and half the height. This dot height times 0.5. If new position dot x coordinate is less than 0 plus half the width, then we need to say new position dot x is equal to half width. Wait, isn't there like a clamp function for this? Hold on, vector 2 dot clamp, right? Wait, new position dot clamp? No, mathf dot clamp. Oh, it only works on ints and floats. Hang on. Oh, okay, this is what we do. We do mathf.new position.x is equal to mathf.clamp new position.x. It can't be below half your width, and it also can't be above the stage.instance.width. Technically, this variable, we should make it read-only, but I'm not going to worry about that right now. And new position... Actually, wait, can I just... Is read-only a keyword in C#? I can't remember. So if it is, I can just do that now. read only. Oh, okay. Good. Oh, shoot. There we go. Make those read only and public static read only. No, I don't want to make that read only. It's fine. It's not really the best programming practice to make that thing public, but we're not too worried about that. Clamp. Oh, I should just copy this. There we go. Y position, Y equals Y half height, and dot height. Let's see. Send me some boss graphics. Oh, cool. Can you make a script that destroys items if they spend a certain amount of time out of bounds? Yeah, I could actually. That might be good for... That could be good for some things. I think what I'll do for the enemies is that I'll give them the script out of bounds, destroy out of bounds, but I will disable the script initially and then give the enemy a timer. And then once that timer, like, let's say, no, what I'll do is I'll have the enemy check when it gets... Yeah, I'll probably give the enemy a timer, like 5 seconds or whatever. And after that timer expires, it will activate that script. So after 5 seconds, if it's still out of bounds, or if it goes back out of bounds, then it will destroy itself. So that's probably how I'll do it with the enemies. Let's see. Can't wait to see the boss. Not nearly as exciting as you might think. Cool. I like that because you're doing all the pixel graphics pies, it means that everything is just going to look consistent, which is actually really cool. And I really like that. Okay, so get rid of this. Okay. Oh, whoops, hold on. The width of the stage minus half your width, and the height of the stage minus half your height. That way, because we don't want the center point. Well, you'll see how this works. Will this work? I think this will work. I just have to set my width and height. Okay, so right now my width and height are 0. So what that means is that the center point of the character can't go out of bounds. But we don't want that. We want we want this character to have a width and height. So how wide is this character anyway? I forget. Let me check this thing. How big is this sprite? This sprite is 14 by 16. Gotcha. And then I multiply that by 4. So 16 times 4, that's easy. That's 32, 64. And 16 times, what was the other one? 14. 14 times 4 is 40 plus 16 is 56. There we go. And now our feet should not be able to get... boom. Perfect. Perfect. Yeah, look at that. Can't go up. And... Oh, yeah. Looking good. Looking good. In fact, if I stand here, they don't even... Oh, they appear a little bit. That's really nice how, like, for one frame, they appear on my hair. Cool. All right. Yeah, this is now a game jam, apparently. Awesome. Thank you so much for helping out, by the way, Pies. Okay, so we have a player. We can move around. We can shoot stuff, but we have nothing to shoot yet. Let's see what enemies we got over here. What did Pies hook us up with? 2, 5. Let me hydrate while we check out our Mr. Enemies. What is this? It's like a brainiac. Oh, that's interesting. I'm gonna have to start adding animations soon because I wanna see this animation. Oh, he's got. Oh, that's cool. Is that a turkey? Oh, is it? Thank egg. I don't know why that's a global emote. It just is. The flapping there is just since they'll be glinding. It's an ostrich thing. Cool. All right, let's make our sprite. Whoops, hold on. Multiple sprites. Sprite editor. So let's start with this sprite for now. Okay. Assets, one enemy, normal. Actually, let's just let's call it frame 0. Okay. And then we have another one here, which is frame 1. We have another thing here. which is the egg. Egg. Okay. Apply. All right. So now we're gonna make an object for our enemy. Man, this is so much smoother now that I don't have to use Krita to try to draw stuff. This is so much better. Wow. This is like Pies, you've actually single-handedly made this stream like literally twice as good at least. Oh, excuse me. Okay, we're gonna call this a Osti. It's Osti the ostrich. Okay, we gotta first I'll put them in the center before it messes, or 0, so nothing messes up. Okay, they're all 0, right? Okay. Osti the ostrich. 2D objects, right? Are they watching a movie up there? Anyway, yeah, I don't know if you can hear that over the microphone or not, but there's like definitely background noise that I could imagine. Yeah, setting up all the hitbox and all that with there. Yeah, it definitely helps too. But like, I mean, like, look how much better that looks compared to this thing. I'm not even gonna call it player. I'm just gonna call this whoa. Okay, sprite. Which song is this again? I like this song a lot. So let's just have 1 frame for now. Okay, and we'll give Osti a rigid body first of all, because they're going to be participating in collisions. Oh, you know what? Now that I'm doing collisions, I think player here actually has to be player hurtbox. Yes. And then Osti is going to be enemy hurtbox. Yes. And actually, the bullet here has to be player bullet hitbox. Yes. So I think the rigid body has to be on the correct layer. I'm not sure, but I mean, can't go wrong with this. So we'll make this thing here be the hurt box. I guess we'll just call it a hitbox because it can also hit the player. No, I guess I'll call it the hurt box. Well, actually, I can give the enemy a separate hurt box and hitbox if I wanted like running into the enemy to be more difficult. But I think I'll just make it the same hitbox for now. Just use the hurt box for both. Okay, 2D. Box collider. So how big is this? I don't feel like doing math. Let's just do this until I get the right size there. It's 6. Wait, can't be 62. It has to be 64. There it is. Now it says 64. Hey, do I want the whole thing to be a hitbox? Sure. Why not? Okay. You're kinematic. Simulated. Okay. Okay, so we got a monster. Okay, we're gonna need some hit points here. So let's make a script. Let's separate these a little bit. Okay, we have a folder for the player scripts and folder for enemy scripts. Let's take all these player scripts and stick them in. Oops, stick them in player. Okay. Enemy. Right click, create script. Call this I don't know, enemy. Okay, this thing's actually gonna. Do I want the HP on the enemy? I guess I might as well. Yeah, no reason to make it too complicated. Enemy movement, I think, is going to be interesting because there's a lot of different ways you can do AI in this game, or in Unity. Wonder how I want to do that. Maybe I'll start with just like simple movement scripts for now. Oh, guy is the true GOAT, greatest of all time. Call it an HH box. Do we need icons for lives? I haven't decided how I'm going to do lives yet. If I needed an icon, I'd probably just take this and shrink it down, but I guess that wouldn't match the art style, right? Yeah, you know what? If you make icons for lives, I can start programming in lives. I think for now, though, you'll have like 1 life or whatever, and then if you die, you die, but then later on I can program in respawning while you have lives. I think I would like to make a UI eventually, but first I kind of want to just get some gameplay going and then work on the UI. Okay. enemy. Oh, might as well give them some movement too, I guess. Oh, you know what? Where's player shot? This thing actually has to have a damage value because we're going to start damaging things now. So player shot. We can call it int public int damage. Damage. There we go. And the enemy is going to have public int max HP and a private int current HP. Okay, and so what's the thing again? It's like trigger on trigger or something. What's the function to when you get the triggers? On trigger enter 2D, I think it is. Oh no, it's on collider 2D, right? On collision, I think. I'm just gonna go to collider 2D. That has the functions. On collision enter 2D. Okay, that's the function I want to do. Okay, collision 2D. Okay. So I believe if I do on void on collision enter 2D, collision 2D. Let's call it call. So I think collision is actually is collision a? Hang on. Wait. Okay, no, it's not. Okay. Let's call it a C2D. There we go. Oh, whatever. Okay, right, so when we collide with something, we're gonna say if, so collision 2D dot, is it called other? Other rigid body. I mean, I guess either one works. Other rigid body dot get, let's see. Let's say, first we'll check if we collided with a bullet, I guess. So player shot, P, player shot, I'll use full description names, why not, equals collision 2D dot other rigid body dot get component player shot. This kind of assumes the player shot component is on the same game object as the rigid body, but I think that's a safe assumption to make. Okay, if player shot is not equal to, what's it, null? I think so, yeah. I think I can just do if player shot, actually. Yeah. So if it's present, then we're gonna say damage player. Actually, wait, this would actually go on the player's end, not me, not the enemy's end, because the enemy doesn't get damaged by the player. Right. Damage enemy. So let's make a function for that. Do private void sustain damage into damage, and this dot current HP subtract equals damage. If this dot current HP is less than or equal to 0, we're gonna make another function for this, private void explode and temporary just destroy game object. Okay, destroy this dot game object. Okay, in the future, this will actually, in future, show exploding animation and play sound. Okay, so this dot explode. Okay. Well, actually, hold on. Disable colliders so we can't participate in any more collisions, I believe is the thing to do. So this dot get component in children, collider 2D. Oh, I think I want for each, collider 2D, C2D in this dot go, C2D dot is dot set dot enabled. It was false. What did I mess up? Whoops, let's get components. There we go. Right? There we go. That returns the array, and then for each collider 2D in the array, disable it. Okay. I am the incarnation of justice. Wait. I am the incarnation of justice, the executor of power, the greatest intellect, the understanding of mercy, the son of Jesus, the savior among saviors, the whirlwind of destruction, the collective consciousness of all human friends, the greatest philosophical being, descendant of Caesar, successor of Nobunaga Oda. I am a great pants. Welcome. Yo, today I also did justice too. I see. That's kind of weird, but okay. All right, so here we go. Oh. Okay. So here we go. So when we get shot, we're gonna say this dot sustain damage, player shot dot damage, and I suppose we should also. I mean, we don't need a comment for that because it's obvious what it does, but we also need a way to tell the shot to explode. Yeah. So there's a couple ways we can do this. We could have the shot also listen for collisions, and then when the collision happens, the shot can destroy itself. But I feel like what we should do is actually have a function here, like public void handle collision with enemy, and we have enemy. Okay, and then for now we're just going to destroy the projectile. This dot game object. Okay. Actually, we can disable colliders so we can't participate in any more collisions. Let's do that first. Okay, we just do the same loop again. Okay, there we go. And actually, this is going to be the same thing. Actually, you know what? Let's just make this a common thing here. Maybe I should abstract this out into a separate component even. But for now, let's just copy and paste it. So yeah, just explode. Boom. When you collide with an enemy, just explode. And then this function, we're going to call it from here. Because other player shots might not destroy themselves. They might want to see if like if you fire like a charge shot, maybe the charge shot goes through the enemy if the enemy has like, if the enemy gets destroyed by it, stuff like that. So actually, let's do that first. This dot or player shot dot handle collision with enemy. This. There we go. Okay. So now the shot can first check and see how much HP the enemy has in the future. And like if the enemy has too little HP, maybe the shot just goes right through it. That kind of stuff. Okay, so all right. So now the shots can collide with the enemy. We should make the player be able to collide with the enemy too. So here we're gonna do. Let's just copy this again. I think. Because I think would the player have HP? I wonder. Maybe I'll give the player HP. Yeah, I'll give the player HP. So it'll be like a Rabby Reeby or one of those games where your ship has HP, like an Undertale, rather than a Touhou exactly. Public int max HP, private int current HP, and I'll just do the same thing as before. Sustain. Oh, wait. I know what I'm missing. Void start. This dot current HP equals this dot max HP. So you start at max HP, obviously. Okay. Boop. There we go. So instead of player shot, this is going to actually be enemy. Okay. And then it's enemy, and then enemy dot. I guess. Let's see. Okay, I guess the enemy can have a function like handle collision with player. I wonder how do we do enemy damaging the player actually? Let's see. Should the enemy explode when it hits you? Or should you get like invincibility frames and the enemy doesn't take damage? I feel like that would make more sense. I think you should have invincibility frames. Let's see. Public int float. What's a good word for it? Invincibility frames. I think I'll just call it that then. Invincibility frames on hit. Or invincibility time on hit. There we go. And private float. Invincibility end time. Okay. And that's going to start at 0. Okay, so this function isn't going to exist. This dot sustain damage enemy. So the enemy has to have... I mean, maybe you just take 1 damage from everything? Yeah, you know what? Let's just do that. For now, you just take 1 damage from everything for now. Okay. This dot explode, rip. But if you're not less than that... Hold on, first of all... Let's do another check here. If this dot invincibility end time is in the future, time greater than time. Actually, if it's already happened, so if invincibility is over, then we sustain damage. And if the damage doesn't destroy us, then this dot invincibility time equals current time plus invincibility time on hit. Or let's call it duration. Invincibility duration, because time I'm going to use to indicate a specific moment in time, and duration will be a length of time. Cuckoo, if I were to send you numbers, would you use as a kind of font? I have no idea. I think Unity usually uses TTF file fonts, but I'm not entirely sure. But I think Unity does use, I'm probably uses TTF fonts, but I'd have to look at that later, I think. But good question. Let's see. Okay, we have invincibility now. That's good. I suppose when I add animation, I can actually... What I'm thinking is I can make the sprite like semi-transparent when you're invincible, but I kind of want that to be handled by a different class. I don't want the player class to worry about that. So I kind of I think I want to make an animation class just to do that. So new folder thing, player animation is a word for an object. We'll call it player appearance, I guess. Maybe like player graphics. Yeah, graphics. Graphics are cool. All right. The player is going to need public player graphics. Wait, is that a keyword as well? Graphics dot. Oh, it is. Whatever. I'm still calling it player graphics. Okay, player graphics. So when you go invincible, player graphics, we need to have a public method called void start invincibility flash. And we're going to have a float for duration. Okay, so then this thing is going to have private float invincibility end time. But also I want to do like the Undertale thing where it flashes slow and then it flashes quickly. Private float invincibility half over time. Okay, and then we're gonna have a public float invincibility slow flash interval and a fast flash interval. Okay. So, okay, these end times are just going to be 0 because invincibility is already over. There is no invincibility. Okay, so when you start invincibility flash, we're going to do this dot invincibility end time equals the current time plus the duration, and also this dot invincibility half over time equals the current time plus the duration, half the duration. Okay, and then what we say is if this dot invincibility. So if the end time is less, well, if the end time is less than the current time. Wait, no. Okay, if it's not over yet. Okay, if invincibility is not over yet. Well, is the invincibility half over? If it's not, then we're gonna do a slow flash. How do I do this? How do I want to do the invincibility flash? I think I can do linear interpolation. Mathf.linear interpolation. Huh. Time. Hum. I think I need private float invincibility. I hate typing this word, start time. I think I need the start time as well. So that's time. Okay. So we need to interpolate between we need, say we have an interval. Wait, how do I want to do this? How do I want to do this? I wanted to maybe like cycle the opacity like a sine wave. Okay, forget linear interpolation. Then I want to do it like okay, let's make a, first of all, public float invincibility flash min opacity. Okay, make that like whatever. So let's call this float new opacity. Float, let's call it I don't know what to call it, but so to make a sine wave, so how do we do this? At the invincibility end time, I want opacity to be maximal, which I think I want cosine then. So the cosine of 0 is 1, which would be maximum opacity. So that's dot cosine of 1, and let's just call it float. T equals cosine of. So we want, so if the current time, so this dot invincibility and invincibility, well, the half over time, I guess, is when it's going to be okay, minus the current time. So that is how long until invincibility is over. And when this equals 0, when these are equal, then the cosine will be 1 and will be at maximum opacity. And then, but I want this to cycle over the interval, which means that if this difference is equal to the interval, I want it to also cosine of that to be equal to 1. Well, the cosine cycles around at 2 pi. So we're going to take math of dot pi times 2, and I guess 2 pi, whatever. Okay, and we're going to multiply that by this divided by the slow flash interval, I believe. So if this difference is equal to the flash interval, then this will be equal to 1, which means the whole thing will be equal to 2 pi, and cosine of 2 pi is 1, and it just loops around. I think that's correct. And when these are the same, this is equal to 0, so it's cosine of 0, which is also 1. Yeah, okay, so I think this will flash with a sine wave with that interval. That's some nice math. So just so if you have a life counter or the like, we need numbers. Nice, thanks. I thought you were actually going to do icons like hearts or something. That's cool too. I could use that for score actually. That'd be cool. All right, so there's our thing. That's if it is not half over yet. And if it is half over, then we got to do the fast interval. So we take the difference of the nth time, the current time, and use the fast flash interval. We'll just assume that the invincibility time is divisible by the flash interval, so that you get a nice curve with this. I was AFK for a sec. I think I missed a lot. Probably. All right. So that's going to be our T, and then we're going to say opacity equals. So when T is 0, we want it to be the min opacity. So we want 1.1 float minus this dot invincibility min opacity. I'm programming an invincibility flash, by the way. Where is it? Here we go. So this amount times T plus this dot, the minimum opacity. There we go. And then we're gonna take the sprite. So I need what's it called? A sprite renderer? Is that what those are? Sprite renderer, yep. And color. I think that's what I want to do is the sprite renderer. So public sprite renderer. Sprite. I think it's let's call it SR. Nope, I don't want you autocomplete. There we go. SR dot set opacity. Nope, set dot color. Okay, I need a util for this. Hang on. I need something to set opacity for me in a color really quick. So we'll call this dot. Let's call it util. And we're gonna have a static class, not a mono behavior. We're gonna have a static method to set opacity. Okay, static void. Color set opacity. Color C float alpha. Or I guess set alpha is the correct word for this. And then return new color. Color dot R, color dot G, color dot B, and A. There we go. Hang on. Although that means hold on. Okay, where am I? Player graphics. We actually need a private float. Private float in invincible. Let's call this default opacity. And on start, I actually want to go and get that default opacity. I actually don't. Okay, this is actually should be here. Boop. This dot default opacity equals sprite renderer dot color dot alpha. Or let's call it default alpha. Symbol default alpha. Oh, F2 just does that? Why didn't I know that? Wait. Min alpha. There we go. Rename symbol. What is alpha? Okay, and then I suppose there should be default alpha minus min alpha. There we go. There is an issue with this, however, that when invincibility ends, I want it to set the opacity back to normal. So we actually need the pool is flashing invincible. Okay, and that'll just start off at false. Let's see. If is flashing invincible. And this is, if this is true, then we are still flashing invincible. Else we are not. And then stop flashing. This dot sr dot color. Okay, hold on. Util dot set alpha. That thing. Alpha. This dot default alpha. This dot sr dot color equals. There we go. Alpha. And okay, there we go. So when we're flashing alpha, we cycle through the alpha like this, and then when we're done invincibilitying, oh, hold on. Wait, hold on. What the dickens? Something got deleted. There we go. Okay. Stop flashing and this dot is flashing invincible equals false. So we actually need to set this to true. You know what? I actually don't need a start time for the invincibility, so we can delete. Oops. We can delete this. I hate these little reference things so much. Let's see. What? Free up space? Oh shit. My recording is getting too big. Hold on. I need to stop the recording. Shoot. How big is... Holy crap. 1 sec. Uh-oh. I better cancel that. Yeah. Hold on. Holy shit, that's a big video. Wow, I just recorded 5 gigabytes. Let me move this somewhere, and then I can keep recording. Gotta rely on Twitch's VOD. Oh, that was close. Thank you, Windows, for warning me about that. Because I forgot I'm recording at a higher bitrate because I'm recording at a higher resolution. So we'll put this video here. All right. Where was I? Oh yeah, let me wait until the video finishes, I guess. So let's see. Let's catch up on chat. This is one way to relax after working on learning some text editing. Hey, what's up, Phantom? Welcome. Your programming has me going. I like your funny words, Magic Man. Sent you some TTF that has numbers on it. Cool. And an X. Nice. And some life icons. Oh, cool. Wow. Okay, I'll get around to that. Wait, what's this thing? Is that the boss? Oh, that's so cool. It's like little heads. Oh my god. Okay. I definitely want to get life icons. Okay, the file's almost finished copying. Moving. Oh, big 5 gigabyte file. And start recording again. Okay. Where was I? Right, so let's get rid of the start time. We don't actually need it. But I do need to set is flashing invincible to true here so that it runs this code. Alright. Okay, this should work. Okay. Alright, I think I'm good with this. I think this will work as I expect it will to make me flash invincible. So when we sustain damage, invincibility time, and we say this dot graphics dot start invincibility flash, duration is this dot invincibility duration on hit. Okay, that should just do what I want it to do then. So that's if we collide with an enemy, we sustain damage. Okay, we sustain 1 damage. And okay. I guess that's if we collide with literally anything. Does that make sense? The enemy, if it collides with the player shot, takes damage. Cool. Okay, I think I can actually run this and it should just work. Let me make a prefab for the enemy though. You know what? I'm gonna make a... I'll just stick it on here for now, whatever. Okay, we're gonna move Asti over here. Oh, can I move this dude, please? Why won't you let me move him like an object? Is it because I don't have the moving thing selected or something? Whatever, I can just put him somewhere convenient. 640 by 300. Okay. And he doesn't have any movement programmed, but if I hit him... Oh, wait, oops, hold on. I didn't set any of these variables. So my max HP, first of all. Wait, why didn't I die? Okay, let's make sure dying works. Didn't. Asti has a hurt box. I have a hurt box. Asti's layer is enemy hurt box minus player hurt box. And we both have rigid bodies, so we should be able to collide. Layer and enemy. Let me take a look at something though. Let's see if we're even getting to this thing. Debug.log collision. Okay. So what's this coded on? So this is coded in C#, and the editor I'm using is called Visual Studio Code, but it can edit a lot of different languages. Like for web development, you can also use this, for instance. Can't die. Cuckoo is too good, just can't die. This is what they mean when they say developers get too good at their games. Let's see. Seems like magic. Then he got into sine waves and math. Yeah, it's definitely important to learn about. Like, I think sine waves are super important for game development. Let's check. Well, can I at least shoot him? Probably not. Is it because... Maybe it's because... Oh, well, for one thing, this doesn't have an enemy script on it. So we need to fix that. Oh, my computer is going real slow all of a sudden. What? Okay, that was weird. Wait. My computer... Why is my computer going so slow? Let me close Firefox. It's probably like screwing stuff up. Maybe Discord. Let me close Discord for now. I can shut off this preview too, actually. There. Okay, let's try again. That was weird. Maybe my computer... I don't know. Maybe Windows is just scanning for viruses or something stupid. I don't know. I hate that the new Windows, like, you can't turn off antivirus scans and stuff. Oh, since I added this script here, let's give it 1 HP. Actually, where's my shot? My shot actually has to have damage. 1 damage. And yeah, so this guy actually, oops. So I need to take this guy and apply what I did to the prefab. So now the prefab also has 1 HP, okay. And I have 1 HP. So maybe the collision should be coming back to me though. Maybe it's because I don't have a physics material, but I don't think that should matter. Maybe it does though. Let's check. So let's call this a player collision. And let's see if the enemy collision's working at all either. Enemy collision. Oh, maybe it's because they're kinematic. Yeah, this song... yeah, it's a good song. Oh, that's what Sour Please is. I keep saying people say that, but I've never actually seen the GIF for it before. I lost 2 out. I feel like something's wrong with our ostrich buddy. Maybe the stuff with the recording. Yeah, maybe. I lost 2 hours of work earlier because Windows didn't do so much as making a notification. Oh my god. Yeah, Windows blows. Okay. You know what? I think it's because they're kinematic. I think kinematic does triggers instead. It's also possible I ran out of RAM or something. I saw it for at least a... Yeah, I don't know who Sour is, but I guess it's some guy dancing in a store. Hydrate. Oh, thank you, Pies. I wonder what that noise is. It sounds like a fridge. Anyway, okay, what was I doing? Okay, right, I think, let me check here. Unity kinematic collision, not working. I think it has to be having a, that's way too old. Collision detection from kinematic rigid bodies. I think it's supposed to be on trigger and not on collision. Oh, to enable all contacts. Oh, wait. From fixed update. Interesting. Interesting. Documentation is outdated about this. Oh, that's interesting. Hmm. Interesting. Okay, let's do that. Project settings, physics, contacts, pair mode. Physics. Velocity iterations, position iterations. Simulation mode, fixed update. Default contact offset. Which one is it? Hold on. Contacts pair mode. Wait, it's only physics? Contacts generation, contacts pairs mode. Oh. Enable all contact pairs, I guess? Okay, contact pairs mode. Does that affect physics 2D as well? I guess it does. Huh, interesting. Huh, okay. Interesting. And I need to do it in fixed update. That's good, actually. I think I do want gameplay to happen in fixed update because that way I can do replays. But then I have to make a little change. The reason is that I want to get input in the update method because I have made a previous shoot 'em up that had issues getting input. I couldn't figure out why. It's because you need to do input polling in the update method, not fixed update. It's kind of a long story why. It's like a Unity thing. But fixed update will always happen at a specific frame rate, which by default is 50 times a second. But I think we can change it to 60. Let's do that. Time. Fixed time step. Yeah, maximum allowed time step, time scale, maximum particle time step. So we change this to be 1 divided by 60, 0.16. Let's just copy this. Okay. Yeah, so now our physics will happen 60 times a second, no matter what. Maximum allowed time step. Okay. This should work. Okay. So now, what I need to do is actually store the inputs that I get in update and then use them in fixed update. Actually, no. I just need to call this method, and then yeah. Okay. Void fixed update. So we run this in the update method, so it gets inputs, and do all the other logic in fixed update. There we go. And likewise, what else moves? The enemy doesn't move yet. The projectile moves. So this actually has to happen in fixed update. Okay. What else is happening in void update? This is supposed to be in... Okay, so I'll just change all the gameplay stuff to happen in fixed update. This class I'm going to delete, probably. Stage. I'm not using this yet. Player graphics. Graphics can actually happen in update, actually. Yeah. Graphics I'll do an update, not fixed update. Movement. Yep, and I need that. Okay, good. Okay. That should now let my collisions work. Frame rate dependent things, yeah. Oh, posture check, thank you. Wait, are all the redeems base 16? They are all multiples of 2, or they're all powers of 2, so basically, yes. I don't know what I should spend my points on. Or cuckoo coins. I don't know. You could save them up and become a boss in a shoot 'em up. I think that's still a redeem on the table, which would be a boss in this shoot 'em up. Okay, what was I gonna do? Let's delete that script that I don't use anymore. This thing. All right, let's see if our collisions happen now. You know what? Let's give it a physics material, just in case. Folder. Physics materials. Create. I don't think I need a physics material, but I better make it just in case. Here we go. Just make it. I'll just call it player. Friction, no bounciness, because they don't use physics. Boop. And give you a physics material. I don't think this is what I need, but let me check. Nope, that didn't change anything. Material. Okay, forget this then. Whatever, just none. Why is it not happening? Simulated? What's this? Oh. Yes. That explains it. Okay. Well, that explains a lot. This one too. And this thing we have to apply prefab. There we go. All right. Oh, wait. Did I put a graphics thing on here yet? I don't think I did. Player graphics. Pop. Okay, put this red renderer on here. Player graphics. Okay. Why didn't I explode though? Player collision, enemy collision. Why didn't I explode? Player collision. Did it get the enemy? It should have gotten an enemy. Okay, let's put that here. And I mean, this should have happened, so I should have sustained damage. Subtract 1. I should have exploded. Oh, let's find out. Maybe it didn't get the enemy for some reason. Yeah. It's not getting the enemy. But this has an enemy script on it. Dot other rigid body. Is there like a rigid body? Is it this one? Wait, which one is? Hold on. Let me check something. Is it this one? The one that I collide with? Let's find out. That would be really weird if other rigid body was your own rigid body, but let's find out. All right, well, that's just that question. So it's, why? Why is it that way? Why is rigid body the enemy's rigid body? I don't know. But okay, that explains a lot. So then the enemy, rigid body, there we go. Get rid of this. Okay, so now I should be able to destroy the enemy too. 4K resolution shmup. Got it. Okay. We got some? Okay, let's give the enemy like, I don't know, 5 HP or something. That seems realistic. And then player we can have like, I don't know, 3 hits. Now we can actually see the invincibility animation. Let's make you invincible for like 3 seconds. So you have like lots of time to get your bearings again. Which means, okay, the minimum opacity, make it 0.5, I think. And we're gonna, okay. So if the duration is 3 seconds, I need something that's, what's 3 divisible by? I can make it 1 and make it like 0.5. Let's try that actually. This is gonna be cool if this flashing animation actually works first try with no bugs. Not bad, not bad. Okay. But I think I need to let's make these faster. 0.25. I feel like I kind of messed something up, but And I die. Is that really lasting 3 seconds though? 1, 1,000, 2, 1,000, 3, 1,000. Okay, it does. Huh. Cool, so it flashes 3 times and then 6 times. I feel like I want it to go faster, maybe. Like when you get hit, bam. But you know what? I actually want. I actually wanted to instantly go to the, like, damaged opacity. How would I do that? But then the halfway point. Where am I? Where's my inventory thing? So half of it is 1.5. I need something that's gonna be like 1, I think. This is kind of difficult without math. So 0.5, it'd be like that. So it'd be like 0.5, 1.5, 2.1. 1. I think if I make this 1, it will actually start me out at minimum opacity. Yeah. Okay. That's good. Oh, so that means that I need 1.5 to be divisible by, let's see, 5? If I divide it by 3, I get 0.5, but that just... It needs to be divided by like 3.5, right? Probably. So, yeah, so 1.5 divided by a decimal number. Yeah, let's do 3.5. That's a weird ass number. No, let's do 2.5 then. 1.5 divided by 2.5 flashes 0.6. Okay. That looks pretty good. Okay. Yeah, so now as soon as you get hit, you go like slightly transparent. I think it's going too and been too dark though. Like I don't want it to go that dark. I want to see where I am. So then we hit this thing. Bam. That's not dark enough though. Like 0.6. There we go. Bam. That's pretty good. Bam. 3, 1, 2, 3. I feel like I want it to flash 5 times maybe there. So 1.5 divided by 5 is just 1.2? Or is it 0.3? Yeah. That's actually perfect. So it'll flash 2.5 times and then 5 times. Boom, 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 boom. Okay. 1, 2.5, 1, 2, 3, 4, 5. Boom, dead. Okay, I think that's good. Alright, that's some good flash right there. It's good flashing. Okay, so now we can get hit. We can shoot the enemy. We shoot him 5 times. 1, 2, 3, 4, 5. Excellent. Alright. We have the beginnings of a shmup now. Let's make the enemy. We gotta give the enemy some AI now. The power ostrich. Let's see. How do I want the AI to work here? I'm going to make it a separate object first of all, because this is going to have a lot of components on it. AI. Whatever. Let's see. How do I want to do this? So I want the AI to have scripts that will do shooting, and I want the AI to have scripts that will do movement. I want them to be separate. So let's see. Enemy. I think what I want to do is I'm going to have a script that controls the enemy's movement. Let's say enemy movement. And what the AI scripts will do is they will call functions in enemy movement and tell the enemy, I want you to move like this far on this frame. And that way, if there's like competing scripts, movement scripts, both trying to do movements on the enemy at the same time, then the movements will add together. That's what I'm aiming to happen. So like if a movement says, I want the enemy to move right, another one says, I want the enemy to move down, he'll actually just move like this. He'll add the two. Okay, let's see. Got some tweets. All right. You expect me to fly to you? no. You come to me, big shot. All right. Okay, so we need to put enemy movement on you. Let's think. And then I'm gonna have, let's make another folder here. Folder, call this AI scripts. And we're gonna have an AI script like say I don't know. What's a movement pattern we can do? What's a simple movement pattern we can do? I could have him just like bounce around at the top of the screen, but maybe I'll do like a, it'd be nice to have like a Touhou movement pattern, right? Where they kind of like drift in one place for a bit, and then they move somewhere else, and then they drift in one place for a bit. So let's see. Let's call this, well, let's have a drift. Drift AI. Yeah, drifting AI. We're gonna be drifting now. You know what? I'm gonna actually separate these into two different folders. I want to have. I know I'm gonna have. Let's see, movement. Actually, yeah. Let's classify them by movement. And we're gonna have another one for attack AIs. And here we're gonna have a script called I don't know, fire. we call it like shoot at player AI. Something really simple. Okay, let's so on here we're gonna have our drifting AI. We're gonna have our shoot at player AI. Okay. So let's see. I kind of want to have like a base AI script as well, because every AI I feel like is gonna well, I can get more complicated later, but for now, yeah, I can refactor things later. So drifting AI, we're gonna have, in order to drift, we need private enemy movement. Okay, and actually the movement class here, what it's gonna do is it's gonna have private vector 2 current movement. And what it's gonna do is on a fixed update, we're gonna, so what we need to have happen here, let's see, if current movement, let's you know what, we can just make a boolean actually, private bool moved, and it's going to start as false, and we're going to have a public method like void move and vector 2 b. Oh, damn it, just want b. Okay, and then this dot current movement plus equals v, this dot move equals true. Then the AIs can call this function to do movements, and then once all the AIs do their movements, fixed update will do if this dot moved and this dot moved equals false, because we don't want to do this twice in a row, and we need the rigid body as well actually. Private rigid body 2d RB. Just call it RB please. And then in start, I really don't like how this thing keeps putting the thing there. We're gonna say this dot RB equals get component in parent rigid. Well, I mean, actually it's just get component there. Rigid body 2d. It's kind of the opposite pattern of what I had before, but whatever, I'm gonna do it this way. So this dot rb dot move position, hold on, vector 2 move position equals v2 dot from v3, this dot transform dot position plus this dot current movement. Oh, we also need to make is not current movement equal to vector 2.0. We need to zero that out after each movement. Okay, I'll do that at the end though. Okay. Reset variables for next frame. Okay. Move this enemy. Some comments. Okay. That move position to new position. There we go. Do. Okay, so now we got some enemy movement. If anything calls move, that is. Okay. Do. So then drifting AI. So at the start, this dot movement equals get component in parent enemy movement. Okay, there we go. So then at fixed updates. Wait, if I do this, So if I do Shift or Alt Shift F, it actually formats the thing for me like this or like this. Oh, shoot. Well, all right. I guess I'll do it this way then. Okay. Alt Shift F. What? Alt Shift F. Alt Shift F. Oops. Alt Shift F. Damn it. Alt Shift F. Oh, it's already formatted. Alt Shift F. Alt Shift F. Oh god, that's actually pretty ugly. Whatever. I can always reformat it later. Alt Shift F. Alt Shift F. Alt Shift F. Alt Shift F. Oops. Alt Shift F. Alt Shift F. Alt Shift F. Damn it. Alt Shift F. Alt Shift F. If I press F before Shift, that's why I get the what? Okay. Shift F. Alt Shift F. There we go. Save all. All right. Now we have consistent coding format. So anyway, we get on fixed update, we're gonna drift around a center point. So the song before the Tankui girl? You mean Tanuki? I've actually never. I don't know this game actually. What song is this? Is this the Desire Drive? Oh, I don't even. Oh, okay. I've actually never played this game. But that's cool. I do like this song though. Let's see. So for drifting movement, I wanted to kind of. So drifting movement is going to periodically. It's going to pick a position near a certain location. So we need like private vector to central position, and we're going to have a public float max. Max variance from center. I could do the Canadian spelling, but whatever. Center, American spelling. Public float. We need drift speed, and we need public float drift interval. So what we're going to do is every interval we're going to drift at a certain speed. We're going to pick a random position within this radius. Let's say max radius from center. Okay, so every interval, we're going to drift a certain speed towards a random position near the central position. And the random position will be at most this far from the central position. Okay, this dot central position equals this dot transform dot position. Oh, you can actually just assign this to a vector too. All right, whatever. Okay. So why does it let you assign a vector 3 to a vector 2, but it won't let you do arithmetic with a vector 2? That's a little bit annoying. Say fast jet. So in addition to this, we have private float next drift time. So every time we hit this time, we're going to pick a new drift location. So we're going to say if this dot next drift time has passed, I guess this will start at 0. Plan to conquer time. We're going to pick a new drift position. Let's make some functions for this. Private void pick new target. Sonic or I'm doing the wrong. I really need to change my code formatting. I don't like having the if statements like this. Mistakes were made. All right. So in addition to this, we need a private vector to target. So we're going to drift towards the target until this time, and then we'll pick a new target. Takes a chance to Sonic Warrior never. So first of all, this dot drift, next drift time equals time dot time plus this dot drift interval. I'll do it at the end though. So this dot target equals, so we need to make a random vector. So we need a random angle and a random speed float. For random stuff, I'm actually gonna, hold on. Why is time changing moments along the way? Where do I want to put the random thing? I think I'll put it in the stage. So where's the stage? So public static random get random number generator. Okay, and this will, let's see, private random RNG, random number generator. And this will just return instance.rng. Okay, and then when we wake up, we're going to do this.rng equals new random. Okay, so we're going to use this RNG specifically. We're going to call it gameplay RNG. And this RNG random number generator will be used only for game actions. The reason we do this is that if we want to have replay support in the future, we can save, we can seed this random number generator and save the seed, which means every time we play the stage in the future, we get the same random numbers. And if these random numbers are only used by gameplay, then you'll get the exact same sequence of random numbers every time. Whereas like a particle effect, if the particle effect might be like you don't care if the particle effects are the same every single time you play. And usually animations run in a separate update. They'd run an update in Unity, but all the gameplay happens in fixed update. So it's possible for the animations to animate at different speeds on different computers. And that's why the animations would use a separate random number generator from the gameplay. So anyway, that's why we're going to do this. So now we can say, I mean, I can just do that. Private random. Whatever, I can just get it now. Random RNG equals stage.get gameplay RNG. And we're going to have float magnitude equals RNG dot. Wait, what? Wait a minute. Wait, what? Why? Wait. Hold on. I think I'm using random wrong. That's for generating random data. That's an issue. That means that that's an issue. Because I don't want my animations to use the same random generator. You know what? Screw it. I'll just use the freaking thing. Whatever. Fine. You win. You win. I'll just use your stupid random thing, and I'll just fix it later when I add replay support. Yeah, it's not like I need this right now anyway, because I don't have replays. So float magnitude equals random dot. I can always make my own random number generator anyway. Like, you can get them off the internet. So I can make my own random number generator code and use that later on when I want to add replay support. Excuse me. So that's interesting. I can get a random rotation, value. What does this thing return? Between 0 minus... Okay. So times this dot max radius from center. Okay. Float angle equals random dot angle dot rotation. What does this return? quaternion. Holy crap, never mind. Just take this and multiply it by mathf dot pi times 2. Okay. Now we can make a vector from this. Vector 2, or this dot target equals this dot central position plus v2 dot from magnitude angle. There we go. So now we get a random vector away from the center, and that'll pick our target. Although this, let's see. I guess it would she'd arrive at the target at a different speed then, because if it picks a random target close to you, I guess I can make this a little bit more advanced to make it more drifty. I'm trying to picture how this is going to look if it only drifts a little bit. You know what? I'm going to change this. We're going to change it to drift interval, and we're going to have a stay at target duration. So the way this is going to work, okay, new plan. We're going to pick every drift interval, we pick a new target, and then we drift at it towards it at a speed that depends on how far away it is from hold on, that means we also need private float speed. So the speed will depend on how far away the target is from our current position. If it's like really far away, like on the other end of our imaginary circle, then we're going to drift to it quickly. But if it's like picks a random target right next to us, we'll drift really slowly towards it. And then after we get there, we're going to stay there for some duration before we pick a new target. So that's going to be a bunch of math. Math is, as you can see, really important for game making. So pick a target. Okay. Once we have a target, we're going to pick a speed. Float distance to target equals, so we have this dot v2 dot from v3, this dot transform dot position, so our current position dot distance. No, okay, well, I'll just do subtraction then. Float this dot target. So subtraction gets you the distance, the vector from one vector to another, and then we're going to take this vector from our current position to the target. Actually, it should be the other way around, but it doesn't really matter for our purpose because the length will be the same either way. So direction to the target from our current position, and tell us, oops, how long is that? Magnitude. There we go. So we want float movement time. It's going to equal the drift interval minus the stay at target duration. Okay. So we're going to move for that amount of time. This dot speed equals, it's going to be the distance. So we need to travel the distance to the target in the movement time. I believe that's it. So if movement time is if movement time is 1 second, then we want our speed to be the distance to the target traveled in 1 second. If our movement time is 2 seconds, then our speed is going to be slower because it takes longer to get there. Okay, that's correct. That is correct math, I believe. And we got next drift time, Tokyo City, big playground. Okay, that should work. Godzilla got pissed and began to attack. I can't sing too loud because it's pretty late at night. Start next drift time. Kind of a general question, but how long have you been coding for? Like today or like professionally? So I've actually been coding since pretty much since high school. So it's been a while. It's been a long time. This is like, and also I code as my job too. So I don't do game coding specifically for my job, but I do coding. So this is like really second nature to me. And I also did a lot of math in high school and university and was just good at it. So the math kind of like comes second nature to me. Things like double checking to make sure I have like division instead of multiplication. Like stuff like that is like second nature to me. It's probably, I can imagine if it goes over people's heads, but it's something you can always, I guess, come back and look at in the file. Like, what the heck was Cuckoo saying? And you just kind of think like, okay, if my distance to my target is 5 units and I want to move there in 1 second, then this will be 1, or this will be 5. 5 divided by 1 is 5. My speed will be 5 units per second, which is, yeah, I'd get there in 1 second. But if I need to spend 2 seconds getting there, yeah, if I want to spend 2 seconds getting there, then I want my speed to be half that, because I get there in 2 seconds. Like, yeah, that makes sense. Okay, yeah, so this is division instead of multiplication. That's math stuff. Okay, so if it's time to drift, what we do is we this dot pick new target. Okay, and then we do the movement. So float or vector to new position equals v2 dot from v3 this dot transform dot position, and add we need a vector. We don't actually need a target position. We just need an angle and a speed, actually. Or no, we don't need a target. Hold on. And get off the white. We don't need a target. All right. We don't need to remember the target anyway. What we need is a movement. Or what's the thing? Velocity. That's the technical term for it. A velocity vector. It's a physics term. Physics is also useful, very useful for game dev. So we don't care about the speed. We just care about the velocity. So this dot velocity is equal to, yeah, there isn't a speed either. Float speed. Velocity is equal to v2 dot from, well, it's going to be, so we need a vector from our current position to the target. Come on, vector 2 dot, so we have target, and then we have vector to target, which is, or I can say like from here to target, which is this here. Okay. And then distance to target is this. There we go. In fact, we can just, whatever. This is easier to understand anyway. We need a semicolon there. Oh yeah, there's no this dot target, it's just target. Okay, so we have a vector from here to the target. Okay, this is the distance to the target. Our velocity is going to be from here to target. We're going to normalize it. What is normalized? Normalized returns. I guess I can do, yeah, normalized, and then times speed. There we go. Okay. So frame from here to target normalized means we get a vector in the direction from here to the target position, but with a length of 1. And then we scale it up by the speed we want to move at. Then we're just going to add this velocity to our position. Yeah. But we actually need to, hold on. We actually need to scale this now, vector 2. Scaled velocity, because if the velocity is like 5 units per second, we actually need to scale that by how much time elapses each frame. So this is equal to this dot velocity times time dot delta time. So let me do that. Good, it does. Scaled velocity. All right, so our new position is here plus the scaled velocity. Okay. And then we say, or wait. I actually want this as our, actually we don't do that, we do this dot movement dot move scaled velocity. There we go. So we tell the movement to do this movement at the end of the frame, or whenever it does its stuff. Okay, so we pick a target and then we just do this movement every frame. Wait, hold up. We have next drift time, but we also have private float stop moving time. So if it's past the next drift time, we pick a new target. Else, if this dot stop moving time. So if it's not time to stop yet, then we actually do the movement. Okay, this isn't going to be a very good drift movement because it's not going to have any like speed up and slow down at the ends. But it could. It could. Hold on a second. Is there a interpolate? Wait, what's it called? Smooth damp. Wait. Smooth step. It's this thing, right? From to T. Interpolates. Okay, this is what I need to use actually. Okay. With smoothing at the limits. So actually, in order to do this, I want to move to, so I can use this to calculate where I need to be on each frame of the movement, and then I use that to calculate how far to move. Yeah. Okay. Shoot, that's going to change things. So instead of the velocity, I need to save my target position. And I need to know my current position. Does smooth step work with vectors too? I don't think it does. I mean, I can do the X and Y. No. Okay, what I do is I just need a direction vector. Wait. So I get the... How do I want to do this? Okay, I think I need to store the start position, the end position, and then I can figure out where between the start and the end position I need to be using smooth step. And then I just use this movement to move to that position. Although, but then if I use a different move... Oh, hold on. Let me think. How do I do this? How do I do this? Smooth step. If I keep track of how far I've moved so far from point A to point B, then I do smooth step to figure out how much further I should move along. I think that will be good enough, which means I need a direction vector and I need a progress or something. Let me try that then. So we have private float progress to target. We need a comment for this one. 0 means we're at our starting position. 1 means we're at our target. There we go. Velocity. Maybe instead of velocity, this is actually just the vector from here to target. And then this is how far along that vector I've moved. Maybe. Or do I need a normalized direction vector? No, I think... How far would you move on each frame then? You would see this is my current progress and this is my progress so far. Get that to get a distance that I need to move this frame. And then that distance is a fraction of the total movement. So I think let's float distance from start to target. And then we have, instead of velocity, we actually need vector from direction from start to target. Direction vector and a distance we need to move. Yeah, I think that's what I need. Okay. So direction from start to target. So we have a vector from here to target. This dot direction is equal to from here to target dot normalized. So reduced to a length of 1, and then distance to target is actually going to be this dot distance from start to target, which is the length of that vector. All right, distance and direction. Movement time is actually going to be, let's see. target. Stop moving time. So this dot progress to target is equal to start at 0 and next drift time. I also need a stop moving time, which is equal to time.time plus this dot. What's it called? Stays at target duration. Oh, this dot drift interval minus this dot stays at target time. Okay, there we go. So that's how long I'm gonna wait. Yeah, this will be the time at which I should reach my target and stop moving. This will be the time that I'll start moving again. Okay. Progress to target. So progress. I don't need anything else computed actually, do I? I just need a direction vector and that. I don't need movement time or any of that. Yeah, I don't need this. Okay. So pick new target. Otherwise, if we haven't stopped moving yet, move towards target. Let's see. I actually need to know when I started moving, do I? No, I don't. I just need to know this amount of time left, right? No, I do need to know how long let's see. Float. Wait, no, I do know how long the movement is, right? Don't I? Yeah. So this is how long each movement is. So I know the time it's going to take. Okay, hold up. Math.smooth step. Okay, what's the start for smooth step? I want to go from 0 to 1. Next, I want floats. And how long has it been? It has been float t equals. So how long has it been? So stop moving time minus the current time is how much longer we're going to move for. So this is how many seconds. Wait. Yeah. Okay. So this is how many seconds. This is how many seconds I have left to move. And this is the total number of seconds that I should be moving. So I think I subtract the two. Or rather, take this and then take this whole thing and divide it by the total time. So hold on. Float. Movement duration, which is this. That's movement duration. And the amount of time it has been the duration minus, this is how much time is left. And so then total time minus time left is equal to time elapsed divided by total time. There we go. Oops. Oh, there we go. That is how far along we are. And so we got, so let's see, float previous progress equals this dot progress to target. And this dot progress to target equals that. So now compute how far we should move towards the target in this frame. Oh, very nice. I can't read any of this. Here, what's up? I don't even know. Like if someone handed me a book in old meetings and told me to read it. Okay. So after we do that, we are gonna. So we have a direction from start to target. So we're moving in this direction. So vector to veloc displacement. This is how far we're going to move is equal to yeah. Okay, I think this is correct. So displacement is equal to, we have to move this direction, and the amount that we move by is equal to progress to target minus previous progress. That's how far we got to move on this frame. There we go. Move towards target. Stop movement, stop move. Displacement. There we go. Actually, I don't need that because that's obvious what that does. Okay. That's a lot of math. I hope that actually works. Like it made sense when I was writing it, but wow, it's a lot of math. Okay. Progress to target gets reset. Stop moving time. Next drift time. Okay. All right. I think this will work. Okay. All right, let's get back to the game. Dang, that was a lot of math just to make this thing drift like a Touhou character. And it's not even like that good because it's gonna pick random positions. Let's see. Okay, first of all, let's start this person out. Wait a minute. Wait a minute. I don't need a central position. Hold on. Do I? So if I want this movement to be able to stack with other movements, I can't memorize a central position. Instead, I actually need to know I need like current target. So I need to know where I moved to. And it's going to start at vector 2.0. So we start where we start. And then every time we move, I'm going to update this current target. So instead of updating using my current position, I just keep track of where I used to be. And then this target here will be next target. There we go. So movement, let's see. Okay. Don't need to know our current position. Okay, so instead of this, next target is going to be so the central position is actually the negative of our current target. So it's actually minus this dot current target. Wait. Wait, how do I want to do this? So if my, hold on, let me do this math in my head. So if my current target's up here, which means I've moved up here, right? And then I want to pick a vector relative to this point, not my new point. So I want a vector in this sphere. So if I take my current point and subtract it, I get to, yeah. And then, so I subtract this vector, then add a random vector. So I think that's correct. I think it is this, yeah, it is, yeah. Wait, what are you doing here? Wait, what are you doing here? Get out of here. So yeah, I think it is, you pick a random direction, but you need to start from negative current target. Yeah, that will give me a new place to, a new vector to go to. And from here to target, it's actually, instead of this, it's actually going to be the vector to the next target from my current target. I think that's the correct math. So this picks a random vector within, yeah, and then a vector to it. Is this correct? Let me think. So let's say I randomly pick this position here. So my random vector is this vector. So I start here. So we take this vector minus that vector here. Wait. Wait, no. No. Okay, this pick a random vector within a unit circle. So there's a unit circle around my current position. Pick a random vector from this starting position. So a random vector in the circle. Let's say I pick this vector. Okay, well, my current target is up here, so I've just moved up here, which means I need to do this movement to get to the new target. So yeah, random vector, move to the next target from my current target. Yep. Okay, there we go. That's the correct math. Now this doesn't depend on my actual position on the screen. So this movement can do its thing while I can put a second movement script on this to move like back and forth around the screen as well. Then it'll have like a small drift movement as well as like a moving, you know what Touhou characters do. They move like this. Something like that. Well, let's see how this works, I guess. Man, this is there's a lot of math, but I think it works. So let's move. How long do I want to move? Maybe like I don't know, 200 pixels or so. Well, this thing is like 64 pixels big, I think. Yeah. So maybe like, what's 64 times? Yeah, maybe move like 128 pixels. And yeah, 128 pixel radius, so I'd be like up to here. This is 64. Maybe up to here. Okay, that's a pretty good radius. Drift interval. How long do I want to spend doing this? Maybe like every 3 seconds. Maybe like you drift for 3 seconds and then you wait for a second. Let's try that. Oops. There we go. So every 4 seconds we pick a new target, but we're gonna spend 3 seconds getting there. I feel like I could have named these better, but let's try this. All right. And you, buddy, you're gonna start. I guess you can start in the middle of it. Let's start up here or something. This is 720. Start at like 620 or something. Actually, it's too close. 500. There we go. Mistakes were made. I mean, it's moving, but it is moving very, very slowly. Hold on. Wait a minute. I think I made a mistake. Well, it's drifting. It's just drifting extremely slowly. Yeah, like all this coding, and I don't even have like a basic shoot 'em up game yet. Although, obviously, like games usually get made by more than one person, except for Zune, I guess. But like, think about how long Zune must have taken to code the first Touhou. That's why like all the future games are very similar to the previous ones, because that way he can reuse all his code. Just like add some new movements and add some new bullet patterns. Why doesn't this work? There's a lot of math here. Well, I think it's this part here that doesn't work as it's supposed to. First let's make sure T is correct. So this should be going from, this should increase linearly from 0 to 1, I think. All right. Why is it wait. So it gets to 7, 8, 9. It's taking a very long time to get to 1. But maybe that's correct because it's supposed to drift for 4 seconds. So 1, 1000, 2, 1000, 3, 1000. Oh, yeah. So it's supposed yeah. I think it is actually working correctly. Like it gets to 1, basically. And then it goes back to, yeah. Yeah, so it drifts for 3 seconds. Okay. So T is scaling from 0 to 1 correctly. Hmm. Oh, you know what I should just do? If I have progress to target, I should just add time to delta time. Yeah. I think so. So, okay, so T. And progress to target. If I log progress to target, it should also take the same amount of time to go from 0 to 1, but it should be smooth at the edges. Let's test that. Let's verify that. One, 1,000, 2, 1,000, 3, 1,000. Yep, okay. And it should be smooth at the edges and move pretty quickly in the middle. Looks good, looks good. Okay, so that's working correctly. It slowly goes from 0 to 1. So why doesn't this thing work? Direction to target is a unit vector. Direction to target is a unit vector. Wait, I didn't use distance to target anywhere in this equation. Oh shoot, that's why. Actually, wait, I don't think I want the unit vector, do I? Hold on. Is this used by anything? Hold on. Oops. 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 I actually just want vector from, hold on. This is, I don't want a direct vector, I don't want vector. I don't care about the distance to the target. So actually, just take this. There we go. There we go, vector from start to target. That's why. Okay, so it was only moving 1 pixel. It was moving 1 pixel every 3 seconds instead of the full distance. That's why. There we go. Wait, where are you going, buddy? You've got to come back this way, right? Wait, where are you going? Where are you going? Wait, no, come back. You're not supposed to do this. It's not supposed to do that. Okay, there's a mistake in my logic. He was 19, I think, when he completed the first one. That's pretty crazy. Like, what makes it even more amazing is that he also did the art, he also did the music. And like, I mean, you've seen how long art takes. Like, well, you've seen how long it takes to make like 1 picture, right? I mean, Pi makes those sprites pretty fast, which is really damn impressive, honestly. But like, think about how many sprites he has to make for all of Touhou, right? Like that, and then the backgrounds too. And then he has to do music composition. Like, every one of those tasks would normally take like 1 person a long time. He did all 3. That's Zuna's crazy. But like I mean, it paid off, I guess. So that's good. It definitely paid off. That's why the art isn't the pro level that we see in other games. Yeah, absolutely. But I mean, it's pretty good, honestly, for like a programmer. I mean, you've seen what I did. I'll take like a Generation 1 Reimu over this thing any day. Yeah. Okay, why isn't my logic working? Because I never updated current target, that's why. Yeah, I never updated current target. So current target starts at 0, right? Where is it? Yeah, it starts at 0. So I pick a new target, I figure out my vector 2 there, then I say this dot current target equals next target. There we go, that's what I needed. That's why he wasn't coming back. Alright, so now it should stay around this position here. Okay, that was just a small random number. Okay. You should come back towards me. Yeah. You should always stay within a circle around the center point. Oh, nice. Wow, look at that. It's actually drifting around the center point. Nice. Oh, that's so cool. Cool. Oh my god, I can't believe like after all that code and logic and thinking and math, it actually works. Because like you never know when you're just like if what you're thinking is actually making sense or is like I don't know if you're crazy. But no, it actually works. Damn, that's pretty awesome. Damn, I don't even want to like kill it. I want to just like watch it move, and it never goes away from this drift center. And in theory, I can actually stack this movement with other movements too. So I can have a movement that makes it come down from the bottom top of the screen, and then it can also start doing this movement as it's like coming down. That would be really cool. In fact, if I just change this drifting logic to pick a target like within a different region, I can actually have it drift like, well, interesting. Look at that drift. Gotta go fast. Man, that's so cool. Just staying around the target. Man, that's cool. I feel like I actually want it to move within a within like a rectangle like this or something. Yeah, I kind of want it to drift within like a rectangle up here rather than within a big circle like this. Interesting. And I also need a bullet pattern. It's alive. Nice, thanks. Thanks, Aura Master. Let's see. So I guess we can just give it a simple bullet pattern now. I guess we need an enemy bullet. Damn, I'm getting tired. Wow. It did take longer than I expected to get this far, but also, like, yeah, this kind of stuff takes a long time. I guess I got a little too lost in the sauce, like doing this stuff. When thanks. Let me watch the clip actually. You should come back towards me. Yeah. You should always stay within a circle around the center point. Oh, nice. Wow, look at that. It's actually drifting around the center point. Nice. Oh, that's so cool. Oh my god, I can't believe like after all that code and logic and thinking and math, it actually works. Good. Yeah. Nice. Always stay within. Oh man, that's so cool. I almost want to stop there, but I did promise a lot. Yeah, I got lost in the sauce for sure. But I did promise to finish some bullets, so let's get that done real quick. Oh, this is some good music for the final stretch. All right, time for some speed coding. So we need a bullet. We're basically going to take the player bullet here. And we're going to, how do I do this again? I'm going to drag it back into here, but we're going to say a new original prefab. We'll call this one enemy shot. All right, enemy bullet. I'll use shot for the player and bullet for the enemy just to distinguish them a bit better. Okay, now we can just stick an enemy bullet here. Sprite is going to be this thing. Bonk. The hitbox on this thing. I think I'll make it a little bit smaller. So maybe like, I don't know, 20 by 20 maybe? That's pretty good, yeah. Maybe even smaller than that, maybe 16 by 16. Let's do that, there we go. Yeah, so you have to like really run your face into that thing to get hit by it. So yeah, it's just like a Touhou bullet, perfect. Here we go, heck yeah, start please. Oh, the song? Yeah, definitely. I'm glad we have the same taste in Touhou songs. Alright, but instead of a player shot, we need an enemy shot script. So we go over here to enemy, C# script, enemy shot. Alright. And for enemy shot, what is enemy shot even going to do? I guess it has to disappear. So I can take player shot and pretty much just copy this to enemy shot. Except it's called enemy shot. It doesn't have a damage because the player always takes 1 damage. It has a speed and an angle, rigid body, magnitude, movement, move. Yep. If you collide with, instead of, we want this to be colliding with player. Player. I mean, I guess we don't care about the player because, well, whatever. And we're just going to explode and, yeah, done. Alright, we need to make sure that this is on the enemy. Is it just shooting forward? No, I'm going to have it target the player. But that will also make it pretty easy to stream, I think. Let's see. There's like so much cool stuff you can do though for like making enemy AIs. Like I actually do have another shoot 'em up game that I've worked on before, and I made this like really advanced system for writing enemy AIs, and it's pretty cool. You can like customize the AIs pretty well. Actually, what was the other game I was working on recently? Oh yeah, I was working on another like a top-down shooting game, kind of like Nuclear Throne. Oh, that game is actually so cool. Have I showed that to anyone yet, or can I? I don't think I would dox myself if I like worked on that on stream. Come to think of it, so maybe I'll start doing that because that thing has a whole bunch of like code for getting AIs to move around and stuff. All right. What was I doing? Right. Enemy bullet, hitbox, everything. Okay. So player shot, you are not. Remove component and add enemy shot. Move this up because I'm pedantic. Sure. Wait, what? What? No. We're gonna apply all. There we go. Where's my prefab? I should really be editing the prefab, not this object. Okay, enemy shot. We'll move this up. Okay, speed. I think these I will actually set from the enemy itself. I won't actually put them here. The enemy will specify these. It's not really good programming practice to have these sitting around here, because if like someone new looks at this, they'll think, oh, why are the speed and the angles 0 for enemy bullets? That's probably a bug. But actually it's because I'm going to set them when the enemy fires it. So it's not good programming practice to do this. I'm just doing it because it's fast. Homing ostrich eggs. I could give them an AI. I'm not good at dodging bullets that change direction as they move, though. I'm really bad at that. So this thing is just going to move straight for now. In fact, yeah. Probably what I would do if I wanted to have homing shots is that I would have a movement script on the bullet that looks at the bullets like let's say it starts with a certain angle and speed, right? It would take that and then program the rest of the homing movement using those parameters. I think that's the way I would do it. Yeah. Okay, so this thing. Why is that thing not set? Hold on. Wait, that should be set on here too, on this prefab. Okay. And destroy out of bounds? Yes. Radius. Oh, whoops, did I not set that? Whoops. How fat is this bullet? And I think the bullets are like 32 by 32 or something. Let's just say radius is 16. Yeah, because each of these is 4 pixels. This is only 8 actually. Okay. How big is this thing? This was like probably 4, 8, 16. It's like 16. All right. Wait, how big is this? Oh, the hitbox is humongous on this thing. Hold on. 16 by 16. There we go. Gotta remember to apply the thing to the prefab. There we go. Okay, yeah, and its radius is 8. That's correct. Half the hitbox. Okay. Yep, your radius is. This one's like, let's do 16, I guess. All right. I think we have our bullet. Now we just need an enemy gun. I guess the enemy gun is actually just the AI itself. There's a few different ways you can design something like this, actually. I think for complicated boss patterns, it makes sense to have a gun separate from the AI that shoots the gun. Because that way you can like have one AI that controls the direction of the gun and a separate script that will control how often it fires. And you can make more interesting patterns that way. So you know what? I'm going to do it. Let's make a gun script. Where is it? Enemy gun. So that means instead of shoot at player, we're going to call this aim at player AI. And we're going to have another script. Let's call it Gatling AI for a Gatling gun. So we need to change the name of this to aim at player. Okay. So this AI just grabbed the movement at the start. All right, these AIs are going to grab the gun at the start. The gun is going to have a bullet. Public enemy bullet. Why is it? Oh shit! Hold on. Should be called enemy bullet. Might be. I want to call them bullets to distinguish between the player shots. Okay. That way I can just say bullet without having to say enemy bullet. But you know. Okay. Enemy bullet. There we go. Okay. So the enemy gun is going to have an enemy bullet. Bullet prefab. And I guess it can have an initial angle. Float initial angle. Yeah. Say public float bullet speed is how fast it will fire the bullets. Or let's say initial bullet speed anyway. So we can vary that as well with scripts. Okay, so it has an angle, a speed, and thing. And we're gonna say so we'll have a public method fire. No, what? Oh, whoops, public void fire. Okay, and what that does is we have an enemy bullet. New bullet equals instantiate. Oops, instantiate enemy bullet. Oh man, I'm like, my posture is all weird right now. I'm like on the side. It also seems hard to program a homing attack that can be dodged while still being a homing attack. Yeah. I mean, you can like, one thing you can do is give the bullet a rate of turn and give it a time that it will home for. That means it can't look straight at you, but it has to turn slowly. And after like 2 seconds, it'll just stop turning. And that way, yeah, that's one way to do homing missiles that you can actually avoid. Hey, what's up, Paula? Welcome back. Okay, we're gonna instantiate this dot bullet prefab. Okay. New bullet. Bullet dot position dot transform dot position equals this dot transform dot position. So we start where the gun is. What else did I do for the gun again? For the player gun? Oh yeah, set the angle and okay. And enemy guns don't have cooldown. The AI will be the AI that controls the gun firing will have its own cooldowns. So bullet dot speed equals. Oh wait, hold on. In addition to firing, we can have public void sets. Set speed. Float new speed, and we're gonna have a private float current angle, private float current speed. I guess I'll start at whatever. I guess when I start, I should set those. This dot current angle equals initial angle. This dot current speed equals current speed. Okay. Oops, initial speed rather. This dot initial speed. Initial bullet speed. There we go. No. Call it bullet speed. There we go. Wait. F2. Bullet speed. Current bullet speed. Initial bullet speed. Initial angle. Current angle. Good. Set speed. This dot current bullet speed equals new speed. And we can have set angle. And later on, I could have like add angle, for instance, as another thing. But there we go. Angle, fire, bullet speed equals this dot current bullet speed. Bullet dot angle equals this dot current angle. There we go. So we initialize the bullet angle and speed to whatever our gun is aiming at, and then it goes, it fires. All right, perfect. We got a gun. So then Gatling AI. Okay, so just like this thing has a private, oh God, where am I? Read private enemy gun. Actually, let's make this public. And I can, that way an enemy can have multiple guns, and the AI scripts can control different guns depending on how you set things up in the Unity editor. So that should be cool. Okay, fixed update. Got gun. I don't know, have a float short. Let's see, interval. It's called the firing interval public float. Bullets, say bullets per volley. Volley interval. And then we're gonna have public float cool down after volley. So the way this is gonna work is that the Gatling gun will fire a volley of this many bullets. The interval between each bullet and the volley will be this much, and then after the volley is done, we're gonna have this much cooldown before the next volley. All right. So private float. So we need, hold on, this should be an int. So we have int bullets fired in current volley. Now we have private float. Next fire time. Yeah, that's it. Okay. And this is going to start at 0. This is going to start at 0. The neat thing about Unity scripts is you can activate and deactivate them, and update only runs when they're active. So you could actually have another layer of AI scripts that enable and disable the Gatling gun AI. So you could have like the enemy could disable this script to stop firing as it like plays an animation, and then re-enable the script to start firing again. That's one of the cool things about like splitting up AI into different components, is you can just mix and match them, and each component just does its one job. So it's very easy to know what a Gatling gun does. It's very easy to know what, well, this AI is a bit complicated, but like you can like imagine your enemy's AI. Like if I was like, when I first started programming, right, I would put my enemy's AI in one big whole class, right? So all of this code would be in a class with this code that would be in a class with like the aiming code, and there wouldn't even be a separate gun. So the whole like keeping track of your current angle and stuff that the gun is going to do, that would also be, all 4 of these files would be in a single ginormous class, and that's just for one enemy. And like, you know, that's not good. But by separating them, you can mix and match scripts to create new enemies. So I can like create another script for like a different rhythm of fire, for instance, and then create a second enemy that's exactly the same as the first one, but with a different firing pattern instead of the Gatling pattern. Or have another script where instead of aiming straight at the player, it like aims back and forth. And then you can just take the Gatling AI and the Drift AI and stick those onto a different enemy with a different aiming script, and you just mix and match. It's really cool. Like splitting up your code into components like this just makes it not only easier to program and easier to maintain, but you can create new enemy behaviors by just slapping together your old enemy behaviors in new and interesting ways. It's very cool. Also, maybe one could program the AI after a certain amount of time to record the player's latest position and shoot bullets in that direction quickly. But for me to have the players paying attention, they can dodge. So probably what this script was going to do was it was just going to look at the player's position constantly. But you can basically do whatever you want and have like all kinds of interesting AI behaviors. So you could have like, 10 different aiming scripts, and you can try them all out by just sticking them on different enemies and see what it's like. Okay, let's see. Let's do this Gatling gun AI. So next fire time. Well, generally, anytime next fire time, once we reach the next fire time, is we're gonna fire something. So we're gonna say, okay, so first we say this .gun .fire, okay, and then we say this .bullets fired in current volley, add 1 to that. Okay, if we just fired, check if we fired the last bullet this volley. If this bullets fired in current volley has now reached this bullets per volley. Alright, it's on new line. Then we say this cool down until next volley. So this next fire time is equal to the current time plus the cooldown after a volley. We're going to reset our bullets thing, and yeah, that's our cooldown. Else, let's see, cooldown until next bullet in current volley. So this next fire time is equal to the current time plus this volley interval. There we go. And we don't reset the bullet count. Okay, that's it. That's the whole Gatling gun script. Lastly, aim at the player. Let's make this one really simple. Fixed update. Okay, so we have public enemy gun. And all we're gonna do is, you know what? We can have a turning speed too, actually. Public float rate of turn. Okay. So all we do is we make a vector to player. That's equal to. So I need the player actually. Okay. So we're gonna make a static method here, so that anything anywhere can get the player whenever they need it. So private static player instance. Singleton object for the player. Okay, we can make multiple players later, but for now it's simple to just have one player, I guess. And then public static player get. And all it's going to do is return instance. And then when we wake up, void awake, we say player.instance equals this. There we go. Now anybody can call player.get to get the player. So now we say player. So we say player.get, which gets us the player.transform.position. Let's see, vector 2 player position equals, there we go, and vector 2 our position equals gun.transform.position, and then we say vector 2 vector to player, which is equal to the player position minus our position, and then we say hang on, it's the gun. So in addition to set angle, we actually need another thing like void turn to angle float target angle float rate of turn. Okay, and what this will do is I believe there's a helper function unity, like turn towards right, move towards angle, float current float target, this dot current angle target angle max delta rate of turn. I don't know, let's just call it max turn. Okay, I think this will do. When they wrap around 360 degrees. Uh-oh. These are all in radians, which means I actually need to shoot degrees. Hold on. Initial angle degrees times math dot degrees to radians. Okay. So I actually need to multiply these. Hold on. Times math dot radians degrees, because this function works in degrees for some reason. And then the result's going to be degrees, so we do degrees to radians, and that's going to be our current angle. There we go. So now the AI says, okay, gun, turn towards, so vector to player is the angle we want, dot. How do I get the, there should be a function to get the angle, I believe. Vector2 dot angle. Angle in degrees between from and to. Oh. Oh, it returns it in degrees. Hold on. Okay, in that case. Turn towards angle degrees. Target angle degrees. Max turn degrees. So this is already in degrees. This is already in degrees. There we go. Oops, I should have done F2 to rename these. There we go. So this is in radians, so we make it degrees, and then we convert it back to radians. All right. So rate of turn, degrees. So, float angle to player in degrees is equal to math dot vector 2 dot angle. So from our position to player position. Okay. Now give us that angle in degrees. And then we say this dot gun dot turn towards. Okay, but hold on. Float max turn. We actually need to take the rate of turn in degrees. Oh, this is also in degrees. And we need to multiply it by the delta time. So if the rate of turn is like 360 degrees per second, we need to know how much we can turn on this frame. And then we say this dot gun dot turn to angle. We're going to do turn to the angle to player in degrees, max turn degrees. Hopefully that actually does what we think it will do. Okay. All right, so now the gun will slowly turn towards the player. Let's try this. So we have aim at player, and then we have and the Gatling AI. So the Gatling AI. Oh wait, where's our gun? We don't have a gun yet. Let's make a gun. Hold on. Okay, let's edit the prefab actually. So close our gun. We'll just leave the gun in the middle, I guess. Well, we can make it more interesting and move the gun down, actually. So move it like, yeah, minus 20 or something, minus 60, I guess. Yeah, that's more interesting. Okay, and we need to add the gun script onto this. There we go. Initial angle will be straight down, I guess, which is 270 degrees. Or we'd say minus 90, I guess, minus 90 degrees. Initial bullet speed. How fast do we want this bullet to go? Maybe like 100 pixels per second? That seems like a reasonable speed. Okay, and then the AI has to know about our gun. The gun, Gatling AI gets a gun. And the drifting AI doesn't need a gun, it just uses movement. Okay, rate of turn. Let's do like 45 degrees per... Let's do 30 degrees per second, so it'll turn like this slow, I guess. And then that should be slow enough that we can see it turning. Bullets per volley. Let's do like 5 and shoot them pretty fast, like 0.1 seconds per bullet. And then after like 5 bullets, wait for half a second, I guess. Okay. Okay, let's see if this actually works. Let's put a new instance of our monster in the game, the level. stick them up here or something and see if it works. I think I forgot to give the gun a bullet. I did. There you go. Okay, I feel like oh yeah, I also forgot to, is the bullet collision gonna work? I didn't even test the bullet. Hold on. Let's stick a bullet in the scene and see what happens. I don't know. Give it some speed. Well, we have a problem, and that's that this thing is not aiming correctly. It seems that it's 0 angle. Also, the teardrops are not facing towards the direction they're going. That's okay, though. Stupid Unity. What direction does it call a 0 angle? It thinks that angle is this angle. What the hell is it doing? So if I move here, yeah, okay, watch. So what does it think is straight down then? Does it think straight down is 0? Where the hell is it aiming? Okay, this is the problem when you have like degrees and radians, and I don't even know where the heck this thing is aiming. Let me see what the documentation says. Angle. The result is never greater than 180 degrees. That makes sense. Which direction is 0? Where the heck is it aiming? They save a lot of paper and I'll print this. Why is this thing not working? I think I need to write my own utility function to do this because I don't think this one's working correctly. Now, it's pretty easy to get the angle. You just use arctangent 2 to get the angle. So let's do that. v2 dot float angle vector 2v, and we just return mathf dot arctangent 2 v dot y v dot x. Or we can actually angle and radians, yep, and we can actually have an even better convenient method, angle 2. So vector v from vector 2 2, and then we just say 2 dot y minus from dot y, 2 dot x minus from dot x. There we go. Oh, that'll give us the angle from one vector from one position to another position. All right. Good old arctangent 2. The difference between arctangent 2 and arctangent is that the original arctangent, if you look it up, it doesn't tell it's bad. Don't use it. It's complicated to explain. The arctangent 2 will give you the angle that we're looking for. That wasn't a very good explanation, but oh well. Float angle to player. Util dot angle to. So from our position to player position. Why is this thing like? Hold on. Oops. There we go. Oh, it's V2 rather. There we go. Okay. Turn to angle. Max rate of turn. Alright. And to make this degrees, we multiply this by rad degrees. There we go. Now, okay. Just to make sure this is actually working, we're going to log angle to player in degrees. Okay. Yes. Hey, it's actually working. It's aiming at us now. Oh god. Hey. Oh my gosh, but the rate of turn is like so slow that it's like, oh my gosh. Cool. Alright, we actually have an enemy. Yeah, imagine, if we had multiple of this enemy, this could actually be pretty dangerous. Let's give, hold on, where's this person? Select the prefab. Let's give you like, I don't know, 50 HP? Let's do like, I don't know. Yeah, we can do 50 HP. Unfortunately, with multiple of this enemy, it will just get easier as we destroy them, but we can always make AIs later that communicate with each other, so they get more difficult when there's fewer enemies left. Alright, let's see. There we go. Let's make the rate of turn a bit faster on that AI, though. That's a little bit, well, I guess that's fine. Maybe make it a little bit, yeah. Bullets per volley. Yeah, the bullet speed is pretty slow too, actually, on the gun. But I feel like that also makes it more difficult. Yeah, like the slow bullet speed is actually gonna make this more difficult because it's harder to dodge between them. Alright. Now they should be able to turn. Oh, I can get rid of this like excess bullet. Hold on. Wow. Okay. There we go. Alright, so now they should all be firing at me. Although the bullets travel slow enough. Oh god. Okay. The bullets travel slow enough that it's not too hard to dodge between them, I guess. Interesting, interesting. Oh, did I put the script on the bullet that makes it destroy when it goes out of bounds? I did. Okay, good. I feel like, what do we need? What song is this? Oh. I feel like we need faster bullets. Let's fire these twice as fast. There we go. Oh god, okay. Alright. Okay, get around there. Alright. This isn't so bad. Okay, this isn't so bad. I think we need more enemies, though. With this. There we go. Okay, let's try this. This game is not hard enough. Okay. Oh god. I think what I also need is like, they should fire at different offsets. Oh my god. Okay, I don't think I've been hit yet. Wait, do these even hit me? Oh, they don't hit me. Hold on. Oh, it's because I never... Hold on. Oh, I'm so good at this game when I can't be hit. So I check if it's an enemy. You know what? I shouldn't even check what hit me, because the only things that can collide with me are things that damage me, so I don't even care about the enemy. Just do that. There we go. It's like my own bullets can't hurt me. Alright, let's just make sure my own bullets don't hurt me. Be good. So if I get hit by these, yeah. Okay, good. Alright. Okay, now we'll actually know if I get hit. Easy game. Oh, god. I'll just wrap around. Oh, god. Oh, shit. Okay, that was a bad idea. Okay, we only got one life left. Fudge. Oh, now it's screwing up because there's no player anymore. You know what? Let's add a check for that then. Player equals player.get. If not player, stop. Okay. There we go. Now it won't give us errors when I die. Alright, I think this is probably where I'm gonna leave it off then. We got ourselves a nice simple game with like enemies that we can shoot and destroy. Eventually. Oh shit, what have I done? Hold on. Oh god. Oh god. Focus this one down. Oh shit, okay. Let's go around here. Okay, we're good. Okay. Oh my god. How much HP do they have? Oh shit. Die. How much HP did I give them again? Okay, got him. Alright, good. Shoot, did I just get hit? Oh, that's bullshit. I mean, I guess it's not because my hitbox is tiny, so it's my fault. God. Okay. Oh my god. Oh, that one went off the screen. Okay. Oh my god. Okay. Okay, we can at least circle around them pretty safely. Okay. What would make this even more difficult? I think the bullets might be going a little bit too slow, though. The turning is a little bit too slow for this to be really dangerous. How would I make these faster? 100. Make the AI guns turn faster. And let's see what our setup looks like. So, yeah, I don't want these to be able to fly out of the display area. Maybe like put them like there and there or something. There, there. I'll put them in the corners here, here. There we go. Something like that. It's too difficult. It looks difficult too. Looks like a shmup to me, so I'd say it was a successful stream. Nice, thanks. Let's see how this looks. Okay, alright. Can I just cheese this by, oh god. No, I can't. Okay, well, if I keep moving quickly, okay. It's not too bad, not too bad. Okay. Okay, this, oh god, okay. This isn't too bad. This isn't too bad. Shh, okay. Oh, fudge, no. Oh, fudge, okay. Oh my god. Okay, this is actually pretty hard. Why am I also move really fast. Hold on. Let me slow down myself. How fast? Oh god, why am I moving so fast? Maybe 400, maybe like half that speed. That's my excuse. There we go. That's better. This feels more like a Touhou, I think. Oh shh! Damn it. Okay, this is actually pretty hard. This is actually really hard. Okay. There's gotta be a way to cheese this though. Crud. Okay, well, okay, clutch moment now. Clutch moment now. Clutch moment. Okay. I just need to kill one of them. If I can kill one of them, this should get a lot easier. Okay. Damn it. You got a key that you can press to make yourself move slower. I could. Although I don't really need that right now. I need to... Okay, I can cheese. I got the cheese strats. We got the cheese strats. Okay. Oh, fuck. No, I'm screwed. Oh, okay, restart. Come on. Let me maximize on play. Alright. That's better. Okay, now I got this. Alright. I'm gonna speedrun. Oh god. No, forget the speedrun. Oh god. No, restart. Okay. Okay, we gotta kite the bullets. No! Okay. No, oh god. Okay. Oh god. You know what? My sprite should actually be behind the bullets. Oh, I got one. I'm not dead. Oh, fudge. Hold on. My sprite should actually be behind the bullets. So to do that, I believe if I make this 1, let's make this like 100. Now my sprite should go behind everything. Perfect. Yeah, that's better. So I want to see how close the bullets are getting to hitting my hitbox. Alright. Let's go. Okay, I can just kite the... Oh, fuck. Okay. Shoot. Okay. Damn it! I'm not used to where my hitbox is. That's my excuse. Okay. Come on, you. Got you. Okay, got one. I got one. Okay. Get through the pattern here. Okay. Oh, shit. Okay, no more damage. No more damage. Shoot, I messed up. Okay, a little bit of damage. Wow, the random movement's actually... Oh god, I'm gonna die. Oh, the random movement's actually, like, messing it up so much. Because, like, every now and then, if they move randomly close to the edge of the screen, it, like, prevents me from circling around them and stuff, and that makes it so much harder. Okay. shoot. I need to like kite them around this. Oh shoot. Okay. Got him. Okay. Calm down, Pecco. Calm down, Pecco. Okay. Shoot. How do I do this? There we go. That's how I do it. All right. Okay. Got him. Okay. I got this. I just need them to like. Hold on. Actually, I don't need them to move. Actually, I think I want them to move. Yeah. Hold on. This other stupid ostrich is like shooting bullets that are getting in my way. I need to like. Hold on. Okay. Here we go. Okay. Got him. Okay. One more. Okay. Why are you down there? Come here. Okay, easy game. Yeah, I did it. The cuckoo's witness the birds. Yeah. Oh. Okay, that was actually really fun. Alright, so I guess that's the stream so far. Oh man, that was crazy. I need to go to sleep. I hope I wasn't making too much noise. Good. Well, I hope people learned stuff. Make sure to save. Oh yeah, it's saved. We're good. But yeah, hopefully people learned some stuff, or just got to see like how game development works. I mean, I guess even if you didn't learn how to do the stuff, I guess it's time to sell the game. It's just like, I guess getting an idea of how game development works is still pretty useful. And like, I know you can see like just how long it takes to make something simple like this. And I mean, we don't even have like projectiles aren't exploding, enemies aren't exploding. There's only one enemy. But there's no pause menu yet. Like there's like, you can see why it takes, so long to make games. But at the same time, it doesn't need to take like forever either. Like you can, I kind of started the stream around 8, I think. So about 4 or 5 hours. Yeah, about 4.5 hours ago is when I started making this. Maybe 4 hours ago, because I spent the first like 15 minutes messing around with graphics to make this ugly thing. So maybe like about 4 hours, I guess, to get to this. And it's like you can actually just make shmup levels you can play now. And if you don't care about the production value, like explosions and pausing and whatnot, it's actually, the game is in a state now where you can actually take this enemy and just like write new AI scripts, and then just like stick the new AI scripts on copies of the enemy, and like maybe palette change the enemy and give it a different color, stick some different AI scripts on it, and bam, you've got different enemies going. Maybe you add like an enemy generator somewhere, like up here, and the enemies can come down and stuff. And there you go. You've got like the functioning shmup. It doesn't have any of the bells and whistles, like a HUD or like a lives indicator, basics. But it's technically a functioning shmup, and you can like make bullet patterns and stuff and have fun trying to dodge them and beat them. So yeah, I would consider this an absolute success. But definitely need to give big shout outs to Pies, because like not having to do the graphics and actually having graphics that look pretty cool, that helped a lot. So let's give Pies a shout out here. Shout out to Pie Sun Creations. I think that's it. I think I spelled that right. Yeah, let's enable the preview back again. How am I looking? All right. So yeah, this is oh my god, Stream Elements. Stream Elements doesn't have permission to post URLs in my channel. Thank you. Oh, nice. Oh, you followed Pies as well. Nice. Okay, that's the right link. But yeah, what was I saying? At the shmup. Okay, I guess I will call it a night. Find someone to raid as well. I think what I'll do is I'll take the shmup as it is now, and I'll put this on GitHub or something, and then when I eventually upload this on YouTube, I'll link to the GitHub branch and version and all that has this version of the game. So you can actually just take this and do whatever you want with it, because I'll release it under like Creative Commons and MIT and all those permissive licenses. Basically, do whatever you want with this. But yeah, just do whatever you want with it. Stream Elements swore. I'm sorry, Stream Elements. I got to give you permission to do URLs. I don't know why it suddenly doesn't work. That's weird. Maybe it just never worked on the stream. Weird. Well, anyway. Oh, maybe it's because I'm actually streaming from a different account. Maybe that has something. Or not this, like, my Windows account is not my usual Windows account, because I don't want to get doxxed on my normal Windows account. So I made a new one for Kakushie. But I don't usually stream on this Windows account because it's too much of a hassle to log into here. So maybe that's why my configuration's a bit different. It's generous to show stuff. Oh, thank you. Oh, I hope it was fun. I'm starting to realize that the lack of organization and planning and me kind of going off on a tangent to get the drifting movement working probably wasn't too conducive to learning how to make a game. But I mean, hopefully it was still fun, and hopefully it gives people an idea of how it goes. I was kind of hoping to make something in only an hour, but I guess that didn't happen. I think if I wanted to make like a Pong game, for instance, I could probably do, like, if I didn't care about stuff like making the AI, what's the word for it? Designed well, I guess. Like if I just hard-coded the AI in a single big Mondo class file and made it really simple and stuff like that, I could probably get this done a lot faster. But I like it this way it's set up here because, I mean, it's so much easier to like if I put this online, right? Anyone can write their own AI scripts, just copy and paste my AI scripts, make your own, and yeah, you're Gucci. So yeah, I'm glad I spent the time to do that. But yeah, I figure I could probably make a Pong game in like an hour, maybe like 30 minutes or less. Even like if I have to draw the graphics, because I can draw a box and create it really easily. I won't spend like 10 minutes on that. But yeah, like it just goes to show, I guess, that you can make games. You can make functional game prototypes without taking too much time. But at the same time, to make a polished game, I mean, you can imagine it takes a long time. But yeah, this was fun. Hope everyone else had fun, because I had fun. I managed to beat my level, so I'm happy about that. Okay, I don't know if there's any other closing thoughts. I feel like I kind of want to do more with this, because I feel like the way I designed this AI system, it's very easy to make new enemies. So I kind of want to do more with this. So I guess we'll see. Maybe I'll do another games like development stream in the future where I just like add on to this, I think. And yeah, and I think every time I do a stream, I'll probably make a new commit on GitHub or whatever. And that way, like if you wanted to see the state of the game after a certain stream, you could just like get the code on GitHub from that particular state or whatever. Yeah, I think I'm actually going to delete. I mean, does anyone want OO? I could just delete OO and not have that like taking up space in GitHub. But yeah, luckily there's no like sound effects. There's not really much stuff taking up space in here, so that's good. But yeah, tomorrow I'll probably try to stream something tomorrow night. I don't know what yet. I could do some more of this tomorrow, or no, actually I'll probably do Genshin Impact, because I want to get to rank 20 before the next patch or whatever drops. Because if I do that, then I can get a free character, Barbara. So I'll probably stream some more Genshin. Personally, I don't think they're very entertaining streams, but I'm just gonna do them and get Barbara, and then I can do more interesting streams again. I should do more with it. Yeah. I think it's time to let OO go. Definitely. It's so bad. I'm trying to think, like, because I don't like to delete stuff, and maybe someone would want to do something with it. But then I look at it and I think, literally no one, of all the like 6 or 7 billion on this planet, I think 0 of them would want to do something with OO. So I'll probably just delete them. I'll tell you what, here's OO. If you want to recreate OO, just take a screenshot of the VOD I know he's pixelated, but he sucks so much already. Who cares? Just take a screenshot of the VOD and smooth him out. Bam. OO is preserved for all eternity. I can delete him from here now. Yeah. So yeah. I think I would. It would be cool, like, continue doing this and like make more enemy patterns and stuff. Because I gotta add the animations, right? So yeah, I'll tweet or something. Oh, this probably won't work either because, oh, this worked for some reason. Okay. But yeah, wait, why didn't the other one work then? Oh, it's because it was like bracket, no game bracket. That's why. Okay, that's stupid, but all right. But yeah, what was I saying? Hey, what's up? Is Cuckoo is making a game? Yeah, I did. Oh yeah. Oh, you missed it. Well, here. So I made this. Yeah, I can shoot them. I think they have like 50 or 100 HP, and each of these shots does 1. But yeah, I made this. Oh god. Oh god. Okay, I can't tell. I actually need to focus. Because this is like it's like such a simple, like, I mean, the people who are here have seen the code, right? All they're doing is turning towards me and firing. And yet it's creating like these bullet patterns that are like actually pretty challenging to get around. Shh. Okay, we're good. Oh my god. Okay. Squeeze through here, squeeze through here, squeeze through here. There we go. Oh my god. It's so cool, like, how you can get such complicated patterns from like such simple programming. Got him. Easy, easy. No miss. No miss. No miss. So yeah, if you want to see how I made the game, it's in the VOD, I guess. That reminds me, I gotta like upload some more VODs to YouTube. Okay. There's like, I want to do the speedrun strats. Got him. Speedrun strats, yeah. No fear. Oh shit. Fudge. Damn it. Oh, I'm actually gonna get hit. That was dumb. I had like all day to see that coming. Oh, well, there you go. You can die in the game too. So this is Space Invader plus Touhou. It's Ostrich Invader. So Pies, shout outs to Pies. I'll just copy and paste this message because Stream Elements isn't allowed to say no game. But yeah, shout out. Oh, I'm not. What? I own this channel, you stupid. Fine. There. You happy? Happy? Yeah, so Pies is the one who made these graphics for me. And he actually made them during the stream, which is awesome. So yeah, there's like me, and there's like animations that I didn't program in yet. What else is in this thing anyway? And then there's like, oh, background tiles. Oh, that's pretty cool. Oh, it's just like my stream background. Yo, Pies, that's so cool. That's honestly so cool. It's just like my stream background. Wow. Let's see. Oh, okay. Huh, interesting. Did Pies send any boss art? I closed Discord. Oh, there wasn't anything important on there anyway. But shoot, why did I close Discord? I think he might have actually. But yeah, anyway, I guess that's it. So yeah, thanks everybody for coming by. I guess you can check the VOD if you want to see everything that led up to this point. And again, I'll make a GitHub account for Kukushie and upload this on there so anyone can download it, you know, get your latest version of Unity and fire it up and make your own AIs and stuff, sticking like different AI scripts onto the enemies. But yeah, man, this is fun. Or you can try to actually beat the level too, because it's pretty challenging. It's surprisingly fun for how simple it is. Thank you, Aura Master. All right. I think it's time to officially end the stream. Saved everything right, yeah. I didn't get around to making sound effects, but you know, you can probably imagine how that'd go. It'd be like, psh, 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 psh. And, ooh. I don't know. Yeah, that's such my stream ending scene that's completely, oh god, I'm cut off. Hold on, let me do some surgery. There we go. Yeah, so I never actually, because normally I stream at 720p, but because I'm capturing my desktop at 1080p and it has small text on it, I decided to stream this one in 1080p, which is why all my stream layouts are messed up. But yeah, thanks everybody for coming by. I'm gonna go find a stream to